Hello. Yes. Good morning, everybody. Good morning, distinguished uh, chairman on the dais, Mr. Reddy sir. Good morning to all the other fellow uh, who are going to present in this first session. I will today present on the water supply tunnels as a conveyance system. This was mainly I will talk on the conveyance system, what is done in the Mumbai city for water conveyance. Mumbai city has having water supply of 3,850 million liters per day. Water supply is given to the Mumbai city every day, and these are through the number of dam sources. Some are in the Mumbai city itself and some are outside the Mumbai city. Next. So water is supplied to the Mumbai city. Some small dams in the Mumbai city itself, that was done in the earlier stages, but majorly water supplying dams are outside Mumbai city. Some are located in the about 100 kilometer to 200 150 kilometer away from the Mumbai city. So water is conveyed to the Mumbai city through these dams by the conveyance system of pipelines. So pipelines which are in the various dia up to 3000 mm, water is supplied to the Mumbai city, and some old pipelines from the Tansa dam, Vaitarna dams, they are very old one, and due to aging, corrosion has happened and number of this pipeline burst has happened number of times. So it was necessary. They are now started. Yes. This is my subject. Okay. the Mumbai Municipal Corporation main office at the CSTM. This is the major sources of the water supply. If you see serial number 1 and 2, that is within Mumbai city, and all other sources 3, 4, 5, 6, 7. These are the sources, name of the sources up to 7. These are the 7 sources that are located up to distance of 100 kilometer. So this is the overview of water supply to Mumbai. These are the number of dams, and from dam, major water treatment plants are at 2 places, bigger water supply, that is the Pandrapur and Bhandup complex. And 2 rivers, main rivers, one is a Bhatsa. From 50% of water supply of Mumbai is coming from the Bhatsa river, and other source is a Vaitarna, Upper Vaitarna, Middle Vaitarna, Modak Sagar, and Tansa. These are the sources. They are coming up to the Bhandup water treatment plant. Total supply that was 3,800, but now it is a change up to the 3,850. This is the network supply, conveyance network outside Mumbai. If you see, these are if you see from the left side, this is the Upper Vaitarna Dam, then there is a Tansa River and Modak Sagar Dam. In between, this new Middle Vaitarna Dam was constructed, and that is commissioned in the year 2014. On the right side, if you see, Tansa River and Tansa Dam is there, and all network bigger size water main 3000 mm, 2500 mm. This is a overall water supply. A Bhandup complex treatment plant. There are 2 treatment plants at Bhandup complex, 1910, plus new constructed in the 2014 is a 900 MLD. And Pandrapur treatment plant capacity 1365 MLD. This is a number of reservoirs. Main master balancing reservoir there are 3, and other service reservoir 26, and network is there. Then these are some components of the water supply. This is a dam. This is a tunnel. Left side it is a dam and tunnel. Then there is a bigger pipelines going from the source to the city, water treatment plant. These are below is the water treatment plant, and this is the last one is a master balancing reservoir. Why water tunnels are required in the Mumbai city? So, first water supply line was constructed to give water supply to the Mumbai city in 1868. This is a 1200 mm dia water main. And then after, these are the riveted water pipelines. They are not welded. And these water mains, after 85 to 100 years, started bursting. There may be some leakages happened earlier, but there are number of bursts and water main burst has happened due to corrosion of the water line. So it was necessary to replace these water mains. But from so many kilometers, 100 kilometers, it is not possible to lay the water main along the highways or major highways, because it will cause disruption to the traffic, as well as there is a much cost if you construct it through the highways. So another option was tunneling from source up to the treatment plant. That option was adopted. So tunnels are generally shortest routes. They are maintenance free, and also losses, pressure losses and transition losses are avoided. In earlier years, what tunnels are constructed, there are about 45 to 50 meters below the ground level. But then after some time, it was arise to need of lay much below the ground level, that is about 100 meters below the ground level. These are the highly pressurized pipe badly encroached by slums also. These are the photos of slums where it was used for number of other purposes. Some people are playing cricket in between two pipelines. So challenges in tunnel construction was mainly basically Mumbai city itself is a land which is a 7 islands are there, and by backfilling this Mumbai city was constructed. So water table is also very shallow level. That is one of the. So also dewatering restriction of drainage pump water due to densely populated area. Then also drilling, blasting required. Blasting and drilling is required for first for shaft, construction of shaft, and then for boring. So for constructing the shaft, there is a, if blasting was used, there are number of buildings nearby. Also, because of blast, the adjoining area population will be disturbed. That was also challenge. Then demucking of the whatever the material from this excavation, that where to dump it, that is also one of the problem. And restricting working hours, that was the restriction. This is mainly geology of the map showing India, geology, how geology varies. So Maharashtra generally having Deccan Trap. So it was suitable for tunnel. Then these are the number of tunnels still we have constructed at number of places. These are the functioning tunnels which was shown up to the 12 and up to 11. 12 and 13 number tunnels are just completed, and they just had to commission. These are the old tunnel from Modaksagar Dam. Yesterday, Dr. Modak in his lecture mentioned that Nana Sahib Modak, that was appointed as a special engineer for the corporation, and in that time he was mainly on this dam as an engineer and special engineer, and his name was given to that dam, Modaksagar Dam. And the old tunnel that is constructed at that time, and now second tunnel was constructed for taking the additional Modaksagar Middle Moitarna Dam requirement. These are the salient features of the tunnel constructed. Tungsten carbide cutters of capacity having 400 to 600 MPa pressures that are used for cutting of this TBM machine. Some tunnels are, some water tunnels are going below the runway of the Mumbai airport also. That was mainly constructed to replace the water main going to the, through the Mumbai airport below the runway. So if in case of any damage to the water main or burst to the water main, there are chances of disruption of air traffic. So that was, water main was replaced with the tunnel. These are layout of existing tunnels, different tunnels, Manduk to Kandivali, these are different tunnels. Manduk to Saddle Tunnel, Ruparel, Malabar Hill to Ruparel College, this is a Sivri to King Circle, these are the different Bhandu complex to Liberty Garden. Then there is a change in the direction, so we have to construct shaft wherever there is a change in direction, we have to construct shaft over there. These are the Behravali to Adarsha. This is a Chhatrapati, where Cross Maidan to Kilachan Garden, this is near Malabar Hill. These are the tunnel constructed. This was replaced the Mumbai line through the Mumbai airport. This tunnel, Gundavli to Bhandup, is commissioned in the year 2014. 15-kilometer length of the tunnel, and total 4 shafts are constructed for this. And diameter of the tunnel itself is 5.5 kilometers. This is the biggest diameter tunnel constructed for water supply. These are the different tunnel locations. I will go fastly. This is a picture of the TBM used for the boring of the tunnel. This TBM assembly was progress. Different parts of the TBM were down itself in the tunnel through the shaft, and that is assembled in the shaft. That is a assembly shaft portion tunnel was constructed. This is the muck, removal of the muck through this arrangement was done. And first time in India, vertical conveyor system was deployed for muck transportation for depth more than 100 meter. This is a reinforcement. This tunnel is just now completed from Ghatkopar, Amarmal to BRC. This tunnel lining was progress and steel was placed. This is the actual work. So Mumbai has long history of this tunnel. First tunnel was constructed in 1953 to 1956. From convey water to Modaksagar Dam, that is Vaitarna Dam. Till date, more than 85 kilometers of water tunnels have been commissioned and operation, and 14.3 kilometers are in progress. They are also nearly completed, and 108 kilometers are in planning stage. These are the different tunnels, and year of construction is given. It is from 1956 to up to 2018. These tunnels are in construction stage. That 15-16 is already completed, but commissioning is yet to be done, and rest of the are in progress. These are the planning stage. So what are the problems arose in the tunnel construction and their remedies? This is the one picture. This tunnel was commissioned in the 2014. While doing this tunnel, I was as a deputy municipal commissioner at that time. This is a concept where soft rock was there. Everything collapse was there from crown portion. So for that purpose, these are the pictures. So collapsing crown portion. So we have provided the reefs. The reef erection work was progress. These are below pictures showing the reef was already done, erection. That is as a support to the soft portion. Then this is the portion where Gundauli to Bhandup tunnel going below creek. While work in progress, all seepage water come inside the tunnel. So there is a flooding like inside the tunnel. That water was removed through bigger pumps, and that portion was repaired. And after repair, that final picture was like this. These are the repair works to avoid that seepage, overcome that seepage. The grouting was done, and finally plate was placed, seal plate was placed above that, that is welded. This is a rock bolting work and mesh work done during the construction. And below picture is a fractured rock after shotcreting work was done. That is a picture. This is a fractured rock tunneling, then reef work. This is a tunnel from Powai to Verauli and Powai to Ghatkopar. This tunnel was in progress during my tenure also. So in that portion, what happened? Below for Powai to Ghatkopar, that portion was below the Powai lake. And while doing that, there is a collapse happened. I will show pictures. So this Powai to Ghatkopar tunnel was difficult to construct, and our TBM machine was below that. It was fixed below that. We cannot remove that. So we have partially commissioned that tunnel from Verauli to Powai, and from Powai to Ghatkopar now in progress. These are the picture, TBM machine below that whatever collapse was happened. This is a TBM machine, collapse portion. the weak rock strata. This is remedial measures we have taken, reef supports. So these are the further planning stage work. This is the. So some difficulties also arise during the, when after commissioning, when we are already supplying water, some problems have happened. I said that it was a maintenance free. Even for 100 years, we don't have to do any maintenance work. But some problems happened. We have experienced some problem. I will show that. The inique and unexpected incidents happened of puncturing of the tunnel. For extracting the water, borewell was constructed some private party in the 10, and during that it was about 60-70 meter below the borewell was constructed, and that was punctured the tunnel itself. And so water was using with a force from the tunnel, that is shown here. So these are the pictures. So we have, after happening that incident, that was first to us, we have never experienced such incident and how to repair that. So we have posted in the various groups, international groups, but response from nobody was reach us, because no tunnels till now was punctured like this. This was happened in the India and Mumbai only. So this was repaired through providing the packers, and then leakage was arrested. After this was leakage arresting was shown. That was in operation. Complete water pipeline was emptied and repairing work was done. This is the welding work. After that, leakage was stopped, and then we have gone inside and what repairing work was there. These are photos or welding work. This is a photo when myself and our staff was inside the tunnel while repairing work. This is a sealing work. After welding completed, it was tested. So then RCC lining was done after welding. So after that, in order to avoid such accidents due to pipeline tunnel damage or puncturing, so we have done GIS mapping of all the tunnels, and these tunnels are passing through different authorities. Some are passing through the Thana Corporation and Thana District Collector. So we have given that GIS mapping to every administrative department who is looking after that area, and we ask them not to allow any borewell in such cases, and we have formed some procedure for allowing the borewell. Earlier it was 200 meter on the either side, no borewell was allowed. After that it was restricted, and we have done it is a 50 meter on the either side, no borewell are allowed in that area. This is the one thing we have done to avoid further such incident. Thank you very much.
Thank you, Bamble sir. Our next presentation is by Dr. Raghuvirao Palapati, Principal Research Scientist. He is a Principal Research Scientist at Department of Civil Engineering, Indian Institute of Sciences, Bangalore. And his subject today is Design of Pipelines and Pumping Systems, Review of Current Practice and Recommendations. I request sir to please give presentation.
Good morning, respected chairman and my colleagues.
I request Ajit Khandeshe for commercial session to come on the dais, and Ivonith, representative of Ivonith also to come on the dais, please.
Yeah, good morning, respected chairman and fellow organizers. So my name is Raghuveer Rao. I'm from Indian Institute of Science. I've been doing this surge analysis for different projects for over 25 years. Till now, I've done about 400 plus such projects. And I'm also training engineers from various organizations in design of pipelines. So you may be thinking, what is this? It's a IWWA conference, and he's talking about design of pipelines. Most of you would already designed hundreds of pipelines, but are we okay with the current practices? I want to just discuss. So, acknowledgements. Let me thank my late Professor K. Sridharan, who has introduced me to this topic, and after which I have been continuing in this, and all my clients who has shown confidence in me, and all the participants of the training programs from whom I have learned a lot of things about design of pipelines. And thanks to Manisha Palande madam and organizers for giving me this opportunity. So what is the motivation for this task? So as I told you, I've been doing this surge analysis for 400 plus projects for various water supply schemes, lift irrigation schemes, micro lift irrigation schemes, and circulating water systems for thermal and nuclear power plants. So everywhere we are going to convey the water through pipelines. So while interacting these people, I found that there are some major issues on these three problems. One is the estimation of friction losses in pipelines, and other is determination of pipe wall thickness for large diameter steel pipes, and requirement of surge analysis. See, most of the times what happens is we have a lot of friction formulae, which I will discuss a little later. And you have multiple formulae, and you have multiple constants, and you are not sure where to use what. Next thing is for the determination of pipe wall thickness, we have several codes. In India, we have 3 IS codes, and we also have one IWWA M1 manual. So when you have multiple standards and with cross references in between, there is a lot of ambiguity and there is no clarity, particularly for younger people to use these guidelines. Experienced people know what to use, what not to use, but younger people don't know this. That I want to clear. And most of the times is surge analysis. Most of the times when you tender the project, then you will say surge analysis has to be get it done by some institution or some individual. Or if somebody else has done, if the contractor has done his own surge analysis, you have to get it vetted by some particular institution. In India, hundreds of such projects will be going on throughout the year, and you can't get these vetted or designed by a particular institute or even particular set of institutions. It is not possible. So as far as possible, now how we are designing pipelines, same way, we should empower ourselves to get this analysis, to do the analysis for ourselves. In rare cases, like some extreme projects where the critical and then the design is very tough, then you can get it done by some institution. That's my request. So I will just go through this motivation I have told you, issues, and then we'll see how to calculate pump head using the friction formulae and how to design these pipelines, what are the current codes, and what are the manuals available, and what is the expectations, recommendations after this presentation. So typically, it's not a rocket science to calculate what is the pump head required, right? So you have a source reservoir, you want to supply water here. So the difference between these two will know what is called as static lift. And just you have to calculate the friction losses through the pipe and add some minor losses towards the bends and other walls and etc. in the line. And then you need to assume some pump house losses and then get the pump head. This is straightforward, but only the problem lies here is which formula to use for friction loss calculation. So the Bible for most of the government departments and water boards is this CPHEO manual. Okay. Luckily, this has been revised in March 2024. Otherwise, you have been using a manual which was prepared in 70s, I think. So for about 40 plus years, it was in use. But luckily, now they have changed it. But still, there are problems which I am going to highlight now. So they have mentioned that now you can use Darcy-Weisbach formula. So you have a H is equal to FLV square by 2GD, this formula which all of us studied in our fluid mechanics while studying engineering. Okay, this formula is straightforward, but the only problem here is what should be the F to use. Okay, so then there is another Kohlberg formula which normally nobody is going to use, so I am not going to discuss about that. So then you have Hazen-Williams formula, where it is given in terms of velocity, but you have to convert into in terms of H. Then finally it comes to a form like this. This is the most widely used formula. Though all this is mentioned, now the latest CPHO manual says that there is an urgent need to avoid over-designing of the pipelines. I will show you what over-designing we are doing you. But though they have mentioned here urgent need to avoid over-design, but there are no corrective measures were given in this particular code. However, normal range of Reynolds number is 400 to 10. And then they say about the manufacturing smoothness, all those things are given here. Then they say that have shown that C values ranging from 140 to 145, depending upon the velocity. Okay? And then they say about the motor type and then how smooth the surface is and all that. And then again, they say that metallic pipes are under severe field conditions, carrying waters, corrosion, etc. But obviously, these days, we are not going to put any bare pipe anywhere. We are always putting some internal coating and external gunneting, or these days, you are mostly going for epoxy type of coating inside. And the design purpose of C values is same as that for new pipes or lesser. Though it is mentioned here, there is a table here where they mention again, recommended C values C 140 for new pipes, and for design purpose 100. This is a bit ambiguous. So at the time of designing, you will take 100, and at the time of execution, suddenly you will switch over to 140. Is it possible to change the pump head from design to the execution so fast is the question. Then projection method for cement mortar line pipes. Here it says again mild steel pipes 130, 110. And then there is something like, no, in the absence of specific data, you can use 130. And if you want to use Darcy-Weisbach formula, then cement mortar epoxy lined iron steel pipes is 0.012 to 0.02. Okay? So what is the difference between these F values versus C values? We'll just see now. So basically, this conversion from Hazen-Williams to Darcy-Weisbach is through this Moody's chart, where you will determine the surface roughness, and then get that surface roughness, and then try to get the friction factor. That friction factor you will equate it to Hazen-Williams formula and get equivalent C. But the implication, if you see here, if you take F.01, C corresponds to 166, which nobody is going to use. And F corresponds to 0.02, then C will be equal to 114, which again, no water supply irrigation projects can use this type of C value. Now, if you want to go by the surface toughness measurements, these are surface toughness measurements. I myself made it for a project with electro steel. So there we have measured the surface roughness for a DI pipe with internal cement mortar lining. So as you know, this H calculation based on this will depend upon the velocity, where normal velocity through the water pipelines is 1 meters per second. If you get a value of C156. Again, this is very high, which nobody is going to use. So what it shows is that you cannot simply rely on C value based on surface roughness measurements. So again, this CPHO manual continues to say that no reduction in capacity with age, decrease in cross-sectional area due to accumulation of deposits in interior pipes, and increase in roughness. And then they say that you have to use Darcy-Weisbach formula and Kohlberg formula. And little later they say, if there is a choice to use pipe friction formula, Darcy-Weisbach, which yields accurate results, can be preferred over Hazen-Williams formula. This is a very contradicting statement with respect to the previous provisions of the code. However, no other formula head loss in pressurized pipeline, pipe flow conditions should be used. At least for me, these two statements are not making any sense. And they are saying here how to determine the C value of existing pipelines. They are giving an elaborate procedure of taking only some 105 meters length of pipeline. Why? All of us have access to hundreds of such schemes which are working, which are recently commissioned, which are commissioned 40 years back. We can simply take measurements of pressure in the pump house and the velocity. You can calculate the discharge using your flow meter, and then just back calculate the C value. That is the simplest way to do it. Why you have to go for an elaborate procedure like this, which is not going to give you any sensible results? So this minor heads generally will use the formula kV square by 2G. So here K has different values ranging from 0.3 to 5 or something. Okay. Anyhow, this is going to be used only within the pump house. And within the pump house, when you want to use such formula, for every valve or any other provision in the pump house, you should have adequate approach length in the upstream side and downstream side, which won't be there. So when these things are very close to each other, we need to, when these things are very close to each other, we cannot use that kV square by 2G, which will be about 0.02 something. So finally, you will get a fraction of a meter, which is not true. So you have to have a lump sum for the pump house losses. So then, luckily, the current version of CPHO manual does not include this modified Hazen-Williams formula. Previous version, it was there. And they used to recommend this formula against Hazen-Williams formula, saying that that is dimensionally incorrect. Even this is dimensionally incorrect, so it doesn't make any sense whether you use that formula or this formula. But they used to recommend a C value of 0.85 to 1. When you use 1, that C corresponds to 149. Again, this goes to one extreme. But there they used to say add residual head at the terminal point and then rounding off. So by with these two, they used to again come back to C value less than 140 or below. So instead of doing all that, directly you can select what is the corresponding Hazen-Williams C required and use appropriately. So based on some measurements in the field, it has been noticed that C value, if you back calculate, C value will be between 120 to 130 plus 10% minor losses, whether the scheme is recently commissioned or measured for over 30 years old scheme. So conclusion is simply you cannot rely on CR values based on surface roughness measurements alone. Now what are the C values people are using? Now, if you see industry like thermal power stations, where the major work is producing the power, so they don't mind about these small water supply schemes within the plant, so they will use C values like 100. On the other end, water supply schemes which involve very high investments, so they wanted to go for C value very high as 145 to 150. So, but actual measurements showing that between 120 to 130. So now you have to think which value to adopt. And how to achieve this proper C value between 120 to 130 is, main problem is that you have, on a cross-country pipeline, you have lots of peaks and valleys, where you need to evacuate the air completely. You generally provide air walls at 500 meters or 600 meters, so it will not completely remove the air, still some air pockets are there. So wherever air pocket is there, the diameter of the pipe will reduce, and that will induce some kind of your V square by 2G. As the velocity increases, that much of loss it creates there. So now, by looking at that, how best you can locate air walls, you should locate, so that you can completely expel the air, but still some pockets will be there. That's why your C value back calculated is much lower than what you get based on surface roughness measurements. Now, what will happen if you overestimate the head or underestimate? So when you overestimate the head, you will have higher discharge at actual head, which is lower than the design. And if you want to pump into a water treatment plant, then you need to curtail that. So for that, you have to start throttling. Then you will lose the energy. So this is very important. Then you have to do some kind of system resistance curve analysis and try to get the correct discharge you are going to get and then control it. And particularly when several pumps are in operation, if you want to run fewer pumps or higher pumps, then the discharge won't be correspondingly higher. That will be based on the system resistance curve, which you need to estimate. And now if you see, we have different types of pipes. So basically, any pipe has to function two ways. One is that it has to withstand the maximum internal pressure, and then it should not collapse by buckling. So for that, what we can do is, we can just check what is the pressure it has to sustain. So that depends upon the working pressure, and you leave some margin over the working pressure, and then see how much surge it can take up. So these are some terminology which we'll use while designing the pipelines. So now the first pipe, if you see the DI pipes, the DI pipes are very easy to design because you have a table given in the IS 8329 where it simply shows what is the allowable operating pressure for the particular type pressure class of the pipe, and then you have allowable maximum operating pressure including such. So in this, there is no ambiguity. Anybody can simply design. But once you go to steel pipes, you have a lot of problem. So here you have three codes, 1916, 3589, and 5822. And I will just show you what are the problems with this. So in 1916, this is recently revised in 2018. And earlier it used to have only up to 3000 mm. Now it has gone up to 5000 mm. So here there is a table given for the thicknesses. So nominal thickness of plate. So for 1000 mm it is 6 mm, and for 2000 it is 10 mm, for 3000 it is 14, and 4000 19, and 5000 is 24. But if you want this pipe to withstand full vacuum as per IWWA M11, you need the minimum thickness of 6 mm. That is okay for 1000. But as you go up, you see the thickness is not adequate to withstand full vacuum. So here case becomes how to control surge pressures with respect to internal vacuum, vapor pressure. So as you can see, the D by T ratio also initially increases and then finally decreases it. Now you have another code, IS 3589, which is reaffirmed in 2022. So it will give you the grades of the steel and then corresponding yield stress. And then it has a table where you have what is called as a preferred dimensions. So this preferred dimension for 1000 mm, it starts with 8.8, okay? So for a long time, this code has made no sense for the actual design. But now recently they have changed it with revisions third, and then here now they are given the minimum thickness, okay? I think yesterday Palanda madam also was telling that this has been revised. Now even if you see here, for 1000 mm, 7.6 mm is provided. So if you back calculate what is the maximum pressure it can take is, if PD by 2T if you take for the pressure, so assuming that our Fe415, which is 2400 kg per centimeter square yield stress, if I consider 50% of the yield stress, 1200 if I equate, it's going to give you P of 18.24 kg per centimeter square. That means it can take up to 182 meters head. Even if you consider 6 mm thickness, it can go up to 144 meter water column. So what does that mean? Why are you going to provide this thickness when you have only 50, 40, 60, 70 meter head also? So it doesn't make any sense. And you have another code, 5822, though this code is for laying of the pipeline. In addition to the details of the laying, there is an annexer here where it says general design requirements, and again in Annex B, there is a calculation procedure for thickness. So that procedure is here, T is equal to PD by, where you consider the design factor and weld efficiency. Okay. And you have another code, design of large diameter steel pipes, where they have mentioned how to calculate the shell thickness, and then given some formula, here everything, based on the loads and what are the limiting deflection values. and how to calculate the compressive stress and tensile stress. But what is the difference between
Sir,
our Indian code versus this one? Yeah, just conclude. Yeah, I will just show you the difference between that and IWWA. IWWA, it is very clearly given that tensile and yield stress, you have to go for working pressure of 50% yield stress and surge pressure 75. This is very clearly given, which is lacking in our Indian code. And what is the minimum thickness required for collapse? You should have minimum thickness of 600 mm for every 1000 mm. And if you use the second formula, 6.6 mm for 1000 mm. So this is not clearly given in our Indian code. And anyway, the minimum wall thickness is based on the handling. For handling, thickness is much lower. So I will just show you one table of a pipeline projects in one particular state and one particular authority. So what are the different thicknesses and the diameters they have taken? You can just see here. So here if you see 2112 mm, minimum thickness is required is 12.6, where hoop stress is only 403. 403 means even if you see for working pressure, you have a factor of safety of 4. Similarly, if you see below, they have gone up to very high thicknesses, 14.2 for 21 mm, and also 1800 mm also is 14.2. Does it make any sense? So what my request is, we should not simply go by these formulas, tables in the codes. We should use our basic engineering knowledge and try to design. In civil engineering itself, in structures and geotechnical engineering, we have very clear factor of safeties, what is to be achieved, 1.12, 1.22, 1.4. Why we are here, we need to go for factor of safety of 4, 5, 6, why? We are simply wasting the steel in the ground. Instead of one project, you can have 3 projects at times. So GRP pipes have nowadays come up very well. But the only thing is GRP pipes has a problem of laying, which we are not fully equipped to lay these pipes, and there are many failures of that. Otherwise, GRP pipe is a very good pipe. So now what is the requirement is, we need a comprehensive code manual, which should be based on engineering mechanic principles, and then for easy understanding of the design, even by entry-level engineers, and we should reduce the cross-references and the less ambiguity it should have. And I request CPHUO, Bureau of Indian Standards, IWWA should work together and try to produce single manual like what we have for IWWA in consultation with the academician practitioners. Thank you. So if you don't do all this, this is what going to happen. You can see pipe will not fail not only by bursting, it can also fail by collapse. Thank you.
Professor Rao, I have a question for you. Can I?
Yeah, sure.
You see, this 3589 was designed by Dr. Nayak was there. I was the convener from the BIS. And this was the minimum has been kept. It's not that thickness has been reduced to a minimum. You can go more higher. It is written in the standard. You see? Yesterday,
yeah.
Right?
Yeah.
So that is the minimum has been kept. And Dr. Nayak was involved, myself involved, and Madam was there, of course. So that was 3589 was designed to take a minimum, and it was written also that if the client feels they need a higher thickness, they can go for. Number one. Number two, if you are having 30% or 25% of higher thickness, your cost of for the project is going to go high. Instead, you can go for a better coating materials. You see, so that is what we felt so. And from BI side, because yesterday Sony couldn't turn up. He is in South Korea. He was from BIS. He could have replied to, but on behalf of BIS, I was the convener. So I am replying that this is the minimum has been considered for designing this system.
I was member of one IS code.
And another thing, you are talking internal cement motor lining. It doesn't last at all. After a few years, it goes off. Cement motor lining, you see, cement motor lining, it makes CaCO hold to, then CaCO through, and then calcium bicarbonate. and goes into the solution. After one
No,
and a
please
half
be
year
brief.
goes up.
Please be brief.
Sorry?
Your time will get reduced. If you keep on talking, your time will get reduced.
Okay, we can discuss that later. Thank you.
Yeah, one question. Last question. No more questions.
Can Mike?
No, Udhar, hi. It is there, sir. Don't worry.
This was represented by the state governments. So it was relaxed for up to May 25 that the earlier provision of 3589 will continue. But after May 25, this minimum thickness has come up. But as you have said that this minimum thickness has made the projects very expensive.
Yes.
And it is not required. So I think this should be immediately changed in the CPHO manual. It's very
Yes.
essential.
Instead of having multiple manuals and
Yes.
codes, we should have one code or one manual which will give you complete information. That is my wish.
Correct.
Thank you, Raghav sir. I now request for today's first commercial session, Engineer Ajit Khandeshe from Kwan Environmental Solutions, Thane District. He is my colleague in MTech in 1991-93 in Vizetia. So I request him to give his presentation.
Just 10 minutes.
So, good morning all, and I thank you IWWA for allowing me to make the commercial presentation. This is regarding backwash water treatment with advanced ceramic membranes. So everybody is aware of backwash water. I need not to explain. So almost 10% of the waste is generated from water treatment plant. We can use ceramic membranes, which will help us to recover this 10%. So if we use membrane, we can remove the clarifier. So 90%. So it can be done with help of ceramic. These are the plates. We can have flux up to 350 LMH. The life expectancy is 20 years. This is a single ceramic plate. This single module. The module makes tower. And this is connected tower. This is out to infiltration, and backwash is in to out. This small video. Is there a click kare video? Video click kar. Video click kar. So you can see the water, good quality water, where the filtration is going. This is backwash has started. Now you can see the separation of the sludge. These are ceramic plates. The sludge gets separated. The backwash aeration and drain will start. And the membrane is clean for next cycle. So there is homogeneous layer shape up, then homogeneous backwash effect, and homogeneous air scouring. So this is the cross section. One can see the membrane plates. At the bottom there is aeration. In the top we can take out the water out. So almost by use of membrane, we can go up to 99.7% recovery. This is backwash case studies. In this case, iron and manganese are removed, and you can see the quality of water. 20,000 is the drain, and we can get the filter quality less than 1. So conclusion, majority of water treatment plant water is recycled back by installation of additional clarifier, and overflow is connected to inlet. This is normally followed in all water treatment plant in India. 5% of total flow is recorded, but it depends upon the skill operations and the plant operator. This is very important. So with introduction of membranes, 98% plus recovery from water treatment plant is possible. Quality of water, treated water is better than gravity sand filter since it is ultrafiltration. It will not overload the system since we are not adding backwash water to the collection sump or the inlet chamber. Costs are less. If we go for a development of new source, then it is almost 7.7 to 8 crore per MLD. This will be less than 5 crore per MLD. More important, this takes care of PFAS. And there is again, with introduction of membrane, we can increase the plant capacity. Actually, we can double the plant capacity by installing the membranes instead of the sand. So this is the one of the cross section where there is a main header, module towers and air scouring fitted in the regular rapid sand gravity filter. And with this, I thank you.
Very crisp and sharp. Thanks. Thanks a lot.
Thank you, Ajit. Commercial session 2, Ivonich, Ms. Muskan Gupta and Wasim Sheikh are here. Please come on the dais. I have announced your name.
Yeah.
10 minutes, madam.
Good morning, everyone. I am Muskan Gupta, and with me I have Wasim Sheikh. We are from Evanit Steel. Yes. So Evanit Steel is a steel manufacturing company. The word Evanit comes from combining two words, evolution and nitya. Here we believe that we have a continuous evolution. So our brand promise is that we are here for a better today. If you see our logo, you can see there are three pillars: here for people, here for impact, and here for excellence. Here for people, we make sure that no one is left behind and everyone feels inclusive when they associate themselves with us. Here for impact, if you see our CSR initiative, you will make sure that we have an impact overall in our society. Here for excellence, we make sure that we produce quality product with best standard policies. So this is an overview of our plant at Wardha location in Maharashtra. We have a capacity of iron making capacity of 1.4 MTPA, and our steel product capacity is of 1.3 MTPA. These are some our corporate social responsibility initiatives. You can see we have our own seed nursery. We have a project Unnati where we tell people about their sexual health, and we also provide scholarship to people. And we have our own medical vans. We have artificial insemination of cows, and we have our own initiatives of empowering women. So we specialize in the production of hot rolled products, that is coil and sheets, cold rolled products, coil and sheets, and galvanized sheets along with corrugated sheets. And we also have an in-house production of hot metal, which we also sell as pig iron. Now just to give you an overview of our manufacturing facility, we'll show you a video.
No sound, ah?
Sound नहीं?
क्या हो गया sound को? As it is, it's quite.
No, we have a good background music and all.
Yeah,
goes
that's good
with
anyway.
it. So anyway, so we'll just so this is our pig. We also make pig iron. So that's the pig casting machine that you can see. Yeah, that's what I'm doing. So that's the hot metal which is produced in the blast furnace. So the hot metal transfer card, that's the overview of our entire steel plant. That is the electric arc furnace where the steel is made from the iron which we get from the blast furnace. That's a continuous casting machine from which the molten metal, the slabs are cast. In the hot rolling mill, after the slab has come out from the reheating furnace, it then goes to the hot rolling mill. Here it is converted into a HR coil. That's the HR coil, which is one of our finished products. So we produce HR coil in various grades, which include various value-added grades for railway applications, for boilers and pressure vessels, for pipes and tubes, etc. That's the cut-to-length line. So here the coils are cut into sheets and plates. Slitting line, we have an in-house service center as well. The cold rolling mill, the HR coil is then further produced as a cold rolled product where the thickness is reduced. And we also have an annealing furnace where CRCA annealed product is produced for the various applications. The CRFH goes for packaging applications as well. This is the galvanizing line. So galvanizing is basically where you do the coil coating with zinc. Zinc is coated on that for corrosion resistance. That's the final packaged product of galvanized. This is where the cut to length is happening for the galvanized product. And after that, it goes into corrugation. So corrugations, this is our galvanized corrugated sheets, which goes into roofing sector. Going forward, we are also going to expand into galvalume as well as color-coated steel as well in the next 1 year. So that's our railway siding, which takes care of outbound and inbound logistics. So that was an overview of our entire Evonith steel complex, which is a 1.4 million ton steel complex with we are a primary integrated steel producer. That's it. Now we can go back to the presentation. Next. So it is our privilege that we got an event like Indian Water Works Association to introduce our product of ductile iron pipe. So this year onwards, we have added a new product to our portfolio, which is the ductile iron pipe, and the brand name for that is Evonith Steel Nectra. So out of a total capacity of 1.4 million tons, the ductile iron pipe making capacity is 0.3 million tons with a Go ahead. Fast. Okay, that's it. So this is our size ranges from 80 mm to 1200 mm. So we cover the entire range of ductile iron pipes, which is used for water infrastructure, water distribution, and various other applications. Next. So the main USP, I would say, is that we are the India's first central located DI pipe plant, located in Wardha. If you can see, all other DI pipe making facilities are either to the western part of the country or the eastern part, and maybe 2 units to the south of India. So about approximately 500 kilometer radius, we are the only DI pipe producer in India, which is strategically positioned to cater to all over the country, all across the country, and it also gives us a competitive advantage in terms of the logistics and transportation cost, as well as faster deliveries to our customers. At the same time, as you saw in the earlier video, we have a good road and rail connectivity as well from Nagpur. That's it. So now, just to end our presentation, we just would like to show a small video of Nectra. So as you must have seen, our stall is just outside the Manthan Hall. So you all are welcome to visit our stall if you need any further details, and you can contact us there as well. We'll just end with a small video of Nectra. I hope we can have a sound this time at least. No? Yeah, I'm sorry, I can't comment on this. So this video is available on our LinkedIn page as well. So if you can just go to LinkedIn or on Instagram also, we are available on the social media as well. So there also you can see the video, we have uploaded it there. And with that, we thank you for your time and end our presentation here. Thank you very much. I'm sorry if anyone has any questions. Either you can ask here or outside the stall as well.
Thank you, Muskan and Wasim. Our next presentation I introduce for Dr. Buddhadev Duwari. Sir is Director of Lalita Infra Projects and NAC Corrosion Specialist. And today's his subject is above ground and underground corrosion of water pipelines and its mitigation. Sir, please.
इसका सामने ये सामने अच्छा अच्छा ऐसे okay. My name is Dr. Buddhadev Duari. I did my engineering from IIT Kharagpur and did my PhD, direct PhD from Jadavpur University in metallurgy. Directly, and it is on metallurgy, and Jadavpur is ranked state university rank 1 in India today. I am, as he said, I am the first Indian corrosion specialist from United States of India, and also protective coating specialist in 2000, back in 2001. I am 67 years old, having 42 years experience in oil, gas and water pipelines. More than 25,000 kilometers of pipeline I have done, pipeline coating in India and overseas. And I have been guiding students for PhDs. The last PhD one person got on the corrosion of stainless steel in Kochi refinery. And then also I have been consultant to Engineers India Limited for their all external projects, overseas projects, and Siemens and other places. Basically, you should understand what is corrosion. Corrosion is deterioration of material or its properties when it reacts with the environment. So cost of corrosion is huge. United States, this is an earlier figure. US is 500 billion. It must have gone up by now. In India, it is about 3 lakhs crores. It is earlier figure. In 2011-12, the RDSO had made a survey. They found out in loss in tanker and wagon is 8,000 crores. Basically, corrosion, you must understand, there's a corrosion cell, electrochemistry. It's basically corrosion. This you will get in books, anode, cathode, corrosion, electrolyte, external circuit. This is about the steel, galvanic series, where you have active material is zinc and passive is platinum. When you keep zinc next to carbon steel, zinc will start corroding because of this is called as galvanic corrosion. So what will happen when you keep steel near the copper, the iron will break into Fe plus, leaving 2 electrons. And these 2 electrons will flow towards copper, that is cathode. And cathode will control the corrosion. Though slowly, steel more and more will go into the solution. And Fe reacts with water, produce FeO is whole 2, further reacts it Fe3O4 and Fe3O4 and finally Fe2O3, which is nothing but rust. And what happens to cathode? What is the reaction happening? Reaction is happening, hydrogen, that 2 electrons, that reacts and produces H2, and finally they produces nascent hydrogen. Why nascent hydrogen? This nascent hydrogen is the one, once it is produced, it happens when you have a cathodic protection system. So this nascent hydrogen will try and leave the coating, resulting in cathodic disbondment. And last reaction, 2H2O, O2, 4A minus gives you 4OH minus. So in cathode, cathode is going to be a alkaline in nature, and whatever coating you are deciding, it has to be alkaline resistance. Otherwise, it will disintegrate. And this is what most important thing. Here, you will not get into books. Here, in a pipe, if it is a bare pipe underground the steel, you will have a pipe with the potential at different point are different. When you get a pipe from the steel plant, you will have one place minus 700 millivolt, somewhere it is minus 400 millivolt. So, wherever there is a high voltage, like water flows from the high level to the low level, same, the potential wherever is high, the potential from the higher potential go to the lower potential, current will flow. So, you can see the anode there. From anode, A means anode, there the voltage is more, the current will flow from to cathode C and back to the pipe is the cathode, back to A. So there will be a lot of corrosion cells if it is not coated. If it is not coated, so there will be a lot of corrosion cells, small corrosion cells, and pipe will get corroding. So this happens when the pipe is underground. Overground, of course, 4 cells are not there. So, Deputy Commissioner Sir, Bombay Municipal Corporation, you have more on higher above ground. So this kind of thing will not come much. So corrosion mitigation by coating. Coating mitigates corrosion through metal surface. Then coating create a dielectric barrier. Dielectric barrier means any coating material has to be insulation resistance proof. Insulation resistance. The higher the dielectric barrier, better is the coating material. And the dielectric barrier should be such a thing, it should take care of 15,000 volts. Why 15,000 volts? You have high voltage lines at the top, and the high voltage lines is minimum 11,000 volts. So the current will come towards pipe if the coating is not more than 11,000 volts coating barrier. This will go and break the coating and drain into the pipe, making corrosions. This is called a stray corrosion. This also will not get in many books. So this is very important while designing a pipeline coating system. Then keeping moisture and oxygen from the creating rust. This is also important. And with coating, that is another secondary system is called as cathodic protection. So coating in supplement with cathodic protection. But unfortunately in India, for water lines, they are not using cathodic protection. Even if they are using, they are not maintaining, because every day you have to, if you are going for cathodic protection system, every week or 10 days you have to check the PSP, pipe to soil potential, every week and record it, and then do all the surveys, DCVG surveys, CIT attenuation survey, all the surveys need to be done. For oil and gas pipeline, it is a must. Otherwise, say it will happen like it happened in Rajmundry. There is a big chaos, oil and it is for a GAIL pipeline. There is a big burst in the pipeline, resulting in death of 22 people. Forms of corrosion: general corrosion, localized corrosion, pitting corrosion. These are the 3 corrosion generally happens in water. Other corrosion generally do not happen in, because intercontinental corrosion and other micro, this happens on oil and gas field. Then corrosion, if this is very important, 9 kilograms of steel in 1 year gets depleted if there is a corrosion current of 1 ampere. For underground pipeline, external, these are the all coating available, coal tar enamel and tape. It is came in 1940s or even maybe before that. Then in epoxy for water, polyethylene tape wrap, then cross-set extruded polyethylene. There is a fusion bonded epoxy is there, but the main problem is this, oil and gas, of course, but the main problem during transportation, it get damages. Then polyurethane for, sir,
Yeah, go ahead. No problem. Move fast. Move fast, sir.
if I don't explain, this is 7 days topic we teach in universities. You have to give some time, sir. And I should have been given before, in between. That's it.
No problem. Another 5 minutes.
Polyurethane is then 3-layer polyethylene and then thermoplastic. This is a new addition. So basis selection of mainline coating, the main important one, type of soil. If soil is very extremely corrosive, that means your corrosive, your ohm centimeter, 0 to 1000 ohm centimeter, extremely corrosive, then the thickness will be more. Then if it is 1000 to 3000, 5000, then that is corrosive, and above 5000, non-corrosive soil. Then you have electrical insulation properties, moisture properties, adhesion properties. These are a very important thing. Then resistance to holiday with time. And disbonding. This is osmotic blistering. That is due to the, if there is soluble salt on the surface, it's not clean after blasting, so that can create a havoc. Then these are the different material, coal tar enamel 4 to 7 mm, polyethylene tape wrap 2 mm, polyurethane 1.5 to 2 mm. Polyurethane, in fact, you should go for minimum 1500, because in case you go for only 1000 micron or 1 mm, there are chances of stray current corrosion, and there will be corrosion entire pipeline. And 3-layer polyethylene 1.8 to 4 mm, they are suggesting many places, but 3-layer polyethylene without cathodic protection is a failure. Then this is surface cleaning standard, white metal, near white metal. This is SP10, SP5 is white metal, SP10 is near white metal. Then other two are power tool cleaning and your hand tool cleaning. These are the three materials. I'm not showing the video, there is no time. Then external above ground, you have intermediate coat, primer, and finished coat. Primer, intermediate coat, and top coat. So these are the three generally, because here the overground, all this corrosion seal doesn't happen. So generally you go for three coats. That means you'll go for the primer, a zinc-rich primer, then intermediate coat is maybe epoxy, and the final is aliphatic polyurethane. And this is the internal lining, Professor Rao. Here is your, we have this, these are the concrete, central spun motor, then solvent-free epoxy, and thermoplastic polymer coating 145, AB value, ABC value is 150. AB is the best, if you can use AB internal lining, is the best one. Thermoplastic also good for internal lining. Then these are the three coating can be used, 3LP, coal tar tape, polyurethane, external. 3LP is very good coating, but only cathodic protection is must, because you have current density, because your pinholes are such a small and the current density is high, so there can be rupture and there can be a pitting corrosion. So you have to have a cathodic protection for a water line if you are using it. Then this is coal tar tape. This advantage is disadvantage manual application. Then polyurethane, you must have the thickness. And then this is internal lining. Then these are the different standards we have drafted. I have drafted on behalf of BIS all the coating standards, epoxy, PU. This is for this is ARP, Action Research Project, is given to me by BIS for fusion bonded epoxy as well as 3LP, 3-layer polyethylene. Now that the standard will come out shortly. Thank you. This is all about. Thank you very much.
Sorry for hurrying it up. Problem is time.
Thank you, sir. There is one more commercial presentation. I call Pratik Srivastava. This by organizing committee has put one additional 5 minutes commercial. So shall I take after?
Next session.
Next session, okay. So, so your yeah.
Om Namah Shivaya. Om Namo Bhagavate Sri Ramanaya. Good morning to all, and there is no time at all to sum up anything. I am happy to chair this session. Luckily, I am lucky to chair this session because I came in time and nobody else were there like the people who are in touch with the subject. I have retired 20 years back and totally I am away from the subject because I am into spirituality and philanthropic activities. But nevertheless, I learned something about the Bombay from Mr. Bombay. I didn't knew that such a huge tunnels were there for the Bombay water supply. And Professor Rao, happy to see him and meet him also because his guru was also my guru, Professor Sridharan. He worked with me as a director of the board when I was the MD for about 5-6 years. Great man known throughout the world, Professor Sridharan from Tata Institute, who is no more. And other presentations were very crisp and good. And I would like to tell one thing. This backside, hello, you people, yeah. See, don't keep, see, this thing is only this. That's why I took the mic. Otherwise, I would have just closed the session. Close your laptops. See this side. If you want to, see, my slogan for the entire 3,000 employees, my organization was, discipline and hard work are the only shortcuts to success. You are all youngsters, backside you are there and I have been watching. Without discipline, even if you are very intelligent, super intelligent, you can't see the success. Time is life. Discipline and hard work are the only shortcuts of success. This you should learn. I've been observing for the last 1.5 years. Some more people have gone, and after doing the roundtable conference, some more people have gone. See, youngsters particularly, if you don't cultivate this sort of discipline and you may be hardworking, but I find the discipline is lacking. So my advice and request to you is be more disciplined, and then the success will follow. So with these few things, thanks Mr. Vaidya for anything. Thanks to Mr. Vaidya for commercial sessions. I must thank them because they are our bread providers, Annadatas. Commercial sessions, they should have been given little more time. I always plead for this in favor of commercial sessions. In fact, we should have given them more time, and even if the sound gave the slip, that was an unfortunate thing. And no, honestly, because wherever there, they should be given at least 15 minutes uninterrupted time for the commercial sessions. And I see this on the board, this Eonith is one of the main sponsors, so also other people. And somehow, because of this delay in programs and too many papers in a session, these things happen. So with these things, thank you very much. Good luck to all. Thanks a lot.
Thank you, sir. Mementos, please. Eonith representative. Muskan and Wasim. have a photograph. Thanks to all. Without tea break, I will continue. Only 4 presentations are there.
Sir,
Yeah.
sir.
जरा मध्ये नको झाल्यावर ब्रेक लंच ब्रेक नाही लंच ब्रेकला आता हे 4 आहेत ना. Our hello delegates. Technical session 2 is challenges of and smart solutions of in water supply and wastewater management. I call speaker Mr. Rajendra Ganatra. Engineer Suprabha Marathi and Engineer Sandesh Paralkar. Dr. Patil to read Engineer Pradeep Joshi's paper. Mr. Anand Jagtap. I request Goyal sir to chair this session, please. इथे आता मोठं लिहून ठेवतो पुढच्या नूर मोहम्मद. Hello sir, have a seat. Suprabha Marathi. Without any delay, shall we start, sir? Our first speaker is Mr. Engineer Rajendra Ganatra, and his subject is structural, financially viable water infrastructure projects. He's an engineer and in his early tenure, and then he became a financial consultant for last 40 years, correct, na, sir? Last 40 years. I request him to give his presentation.
That's right. Oh, thanks a lot. Great. Good morning, friends. The population has depleted very significantly, unlike what you see day in and day out. But I'll make sure that it won't deplete any further. As Mr. Vaidya introduced, I was an engineer for 5 years, then I drifted to finance, did project finance for over 20 years in financial institution, then for 9 years from the corporate sector, and then I have been into this. Even my PhD related to the risk shifting in project finance by asset overstatement, and asset overstatement is a euphemism for padding. That's what happens. I did water project financing, SEZ, urban infrastructure, so I'm aware of it. And the water project financing which I did was Tripur water. And I quote it as my own failure. We had our apprehensions and we did raise, but it failed anyway. Now coming back to this, when we talk of securing, structuring financially viable project, what is it and what relevance has it to the country's well-being and to your own well-being, to the engineer's well-being? We'll be discussing that, and I'm sure I'm going to make it very clear in your mind to use it in your profession. So there's the contents. I will not go through in detail. We are all aware of it. The growth in the government center's allocation can be seen year on year, and very significant growth. Though, of course, this is a state subject, the center does its own part, and both are complementing and supplementing each other. But still more needs to be done. The fact of life is that there has to be private capital coming, there has to be commercial capital coming, and the moment you talk of commercial capital, you can't rely only on the economic viability. There is time when you should also have financial viability. So we'll be clear, I'll make it very clear what is viability, what is commercial viability, what is financial viability, and what is economic viability, and how we'll morph from economic viability to financial viability, right? So we talk about structuring financially viable projects. And the moment we're talking of private capital, we understand that there will have to be a partnership between the public, that is the government, the authorities, and the private, that is the private sector. So I'll not go in through these very components. These are descriptive. Since I have been here, since we had some discussion, I'll be focusing more on the substantive part which should be assimilated by you. But essentially, what I've done here is that I have highlighted certain portions so that, we focus on them. Public-private partnership is supposed to blend the strengths of both the private sector and the government sector. And if it's both the strengths are blended, you're going to get the best results. And the basic principle is that allocation of the infrastructure project risk to the party best placed to mitigate it. Often, this is a very theoretical statement. Because in commercial world, the risk shifting happens and the risk gets placed with the weakest party. But here you can't do that. It has to be done by the party best placed to mitigate. And I'm going to make it very clear to you. And the government authority is expected to mitigate the risks which are under its own domain. In fact, yesterday I had given some examples of that also. And certain risks are shared and mitigated, which is always there, let's say, in case of environmental risk, and sharing of right of the way, etc. Now, if you're talking of fear, responsibility and feature, if you see here, typically, when you talk of PPP, what you are doing, design, build, finance, operate. These remain with the concessionaire. Then there is a transfer from concessionaire back to the authority, or it continues. And there are other features, revenue sharing, old project refurbishing, even in that it's done. I'll add one more thing. If I'm talking of revenue sharing, I can also talk of the viability gap funding. Where a project is economically viable, it must be taken up even if it is not financially viable. But only thing is, what is the kind of viability gap funding that is needed? That can't be done, calculated based on armchair analysis. It has to be discovered in the market. So that's how we can talk about the structuring of viable projects, right? Now we come to the financial viability of the projects. I'm not going to look at that, I'm going to look at you. The moment we are talking of financing a project or taking up any project, we are looking at two figures. One is the cost, another is the value. The cost is largely deterministic, right? You may estimate the cost. The actual cost will be different from the estimate because there will be contingency depending on the sophistication of the project, right? But how much it would be cannot be finalized by anybody in the world except the market. Let it be subjected to the competitive bidding and let the cost be discovered in the market. But still you have the consultants who are high-class consultants who can come up with best of the feasibility study, can help you to budget a cost which will be very realistic. There are many projects which have been set up within the cost estimates with competitive bidding. And only if there is a competitive bidding will the optimality creep in, otherwise it will not be optimal, right? That's one part. But cost is largely deterministic. It takes quite a long time to decide on the cost because conceptual design takes time and finalizing the configuration and the sizing takes time. Having done that, having the engineers do that, engage the best of the consultant and to come up with your project formulation. Cost formulation is also a part of this, the consultant is going to give, but the real cost is going to emerge only when there's a competition. I'll give you 2 to 3 examples, no matter, it's a bit of a repetition. 1992, we had done opened the power generation to the private. And in the 90s, I also got into the project finance of the power projects and other infrastructure projects, including the water projects. The costs were extremely high for the first 8 projects because those were the projects which were given based on nomination and based on a very inefficient tariff formula, right? And one of them was Dabhol Power Company. I don't have to repeat that. The cost of the project for the 9FA technology was 4.92 crore per megawatt, the capital cost I'm talking of. And I had done another project where the EPC contract had been signed with the same 9FA technology. It was 3.22 crore per megawatt. Imagine the kind of a difference. Why? Because the second project which I had done had emerged from competitive bidding. It was tariff-based. It was an excellent design of the bidding parameter. If you talk of IRR, then you're committing a mistake. So there are certain issues there, right? So the moment the cost was high, the promoter, that is Dabhol Power Company of Enron, had to find a way to achieve a value which was higher than the cost, right? So it set the tariff based on the 2-part tariff, which was inefficient. And as a result, for supply of about little less than 500 megawatt of power, to MSEB, which had 8,000 megawatt of power capacity overall, the MSEB's 50% revenue was going for payment of this, power, the energy supply, power and energy supply. It doesn't mean that this was the most expensive. Yes, it was, but then it also showed that the MSE's finances were in doldrums. It should not have been that way. But in any case, this was an example of very inefficient setting in which the project cost was very high, and to justify its existence, the tariff was very high. And the tariff was based on a very bad formula. In case of the other one, which was Gautami Power, which I'm talking of, it was based on a very efficient, competitive, tariff-based bidding. Obviously, it was very less. In our country, the two projects which I've studied in fair amount of detail, the Tirupur water project was based on the most outlandish tariff setting. It allowed the Tirupur water to set a tariff which it wished and continue the operations until 30 years, in which it could achieve a project IRR of 20%. And if the IRR fell short of it, the contract could be extended by 20 years. This was the most inefficient, most exorbitant kind of a tariff setting project formulation. So sowing the seed of creating an unviable project, but somehow propping it up by inducing viability, which is not there. It's coming back. The moment we're talking of structuring financially viable project, as I mentioned, cost is deterministic. Then you figure out what its value will be, and on that basis decide to go ahead with the project or to drop it, right? And there are many projects which get dropped. Incidentally, I had done 3 projects of Reliance Industries Limited in those days, sanctioned. And interestingly, those projects were dropped because they found that the value was not stacking up. Can you do it in water? If the water is needed, you cannot drop it. It has to be done.
Can you please?
But at least what you can do is you can have a very efficient cost. Like, let's say Mumbai. Mumbai, the cost of the bulk water itself comes to 25 rupees per kiloliter, right? Now, if I want to make it a viable project, then this bulk water has to be sold at a price which is higher than 25 to the extent that the operator of this bulk water system, whether it's government or anybody, gets more. How much more? Which will give a required return on its equity. It will have to be done that way, right? So that makes it financially viable. Now, if it is made financially viable, what will happen to the consumer? So that's the other end of the spectrum, where it is distributed, and there has to be somebody who will distribute, and that person will also need to have a certain return. But if the government is there, it is the government's responsibility to allow this public good. How will it make it viable by ensuring that the tariffs add up to the appropriate value which is more than the cost, right? So that's what you must have, so many of you might have done MBA, but might have heard about net present value. The moment you talk of net present value, you are effectively talking of the value exceeding the cost. Therefore, your net present value is higher, right?
Please try to...
Pardon?
Try to...
Shall I conclude, you mean say? How much time do I have?
We have already done 10 minutes.
Okay. So I'll take 3 to 4 minutes. Yeah. All right. Thank you. Right. So let's go further here. This was the project cost, 1163 crore in case of Tirupur water. This came down when the competitive bidding, the procurement guidelines of World Bank were, pressed upon 2 years later. So please understand, the moment you are having a genuine competitive bidding, cost will come down. There was failures here, failure of the Tamil Nadu government on 2 major fronts. Failure on the part of the project concessioner to have the right organization. They had somebody, a bureaucrat who had shifted from Northeast because he didn't want to stay in Northeast. He had no background whatsoever. This is a very specialized activity, and you have to have, like you saw yesterday, Padmanathan from Malaysia. He's an engineer, or you look at even PUB. It has to be that way. Lenders' failure, everyone, even I would say our failure. We had our apprehensions, we did finance, but it was done. OCW, Orange City Water Works, where Veolia came, and where the private sector was allowed to walk away from that in 8 years. Now this was very strange. And here there is no value which has emerged. So, coming back, point is, the moment we are talking of structuring financially viable project, we are talking of a project whose value is intrinsically more than the cost, not artificially. Today it will have to be artificially because you will have to take time to come up over to the stage where you can have really financial viability. So right now, looking to the economic viability, government will have to give viability gap funding, but come up with structures which give you the most efficient engineering, procurement, construction, and commissioning and operations through genuine competitive bidding so that the cost can come down, and going forward, every stage of it is made efficient. Lastly, I had mentioned yesterday also, and I'm mentioning here, in case of Singapore, the Public Utilities Board, which started PPP in 2003, had made a success, and they have delivered value for money, which means the lifetime cost of operating these plants was lower than the authority's cost, which meant it gave value for money. We can't have clearly value for money because our costs are very high, but at least we can begin with the optimized cost so that the value emerges, and those people who are responsible for such best formulation, excellent formulation, should have massive rewards, and this reward can be probably split into certain percentage for the team and certain percentage for the organization. These kind of incentives would work because in private sector, you have huge amount of ESOPs. The ESOPs have to vest in the person concerned over a period of time when the person's, formulation have finally succeeded. Same thing can be done, but yes, it can be done where you have huge rewards for a great job, and you don't have to then look around here and there. Thank you very much, friends. Any questions I can answer? Or maybe you reserve it for later period.
We can take later. Thank you.
The next presentation is Rethinking Property Plumbing for Planet Sustainability. Engineer Suprabha Marathe, retired Deputy Municipal Commissioner of Bombay Municipal Corporation. Please give your presentation.
Hello. Good afternoon. बसंत पंचमी की सबको हार्दिक शुभकामनाएं. Before I start with my presentation, I have a few questions for the audience, and I will request answers to these questions. The group on my left, can you please tell me how much water do you consume every day at your home? Anyone of 6 of you, anyone can tell me? How much water do you consume at your home every day? And if you don't know that, please listen. Okay? Second question, how many of you can tell me if 1 minute you keep the tap open, how much water is wasted? If you don't know, I think you need to concentrate on my presentation. I'm putting up very small and simple things which are very easy to understand, which are very easy to practice, but I think people should know them. And so please concentrate. First of all, before beginning the presentation, I also want to tell that when I joined IWA, the Mumbai center head was a plumber. So nowadays we see more engineers in IWA, very few plumbers. But plumber is a key between the ideas and the consumer. So this presentation talks about rethinking property plumbing for planet sustainability. If we don't have the slide mover, can you please move the slide? These are routine pictures. I just don't have to say much. They are copy pasted. But this is the worldwide use. This is fresh water withdrawal from top 20 countries. We are somewhere 6th, 7th, 8th. Now, the story starts here. As on today, we are actually not facing real crisis, but crisis is not away. We are very near to it. Maybe by next 5 years, we will be under the threat. Now, the major demand-supply gap is in most of the cities because we don't actually calculate and we don't concentrate on our plumbing concepts. And groundwater gets more and more threat, and so many red areas developed. Rainwater harvesting, we are talking a lot, but practicing less. So we are also ending groundwater, which is our God-given storage or which has come over thousands of years. So let us do something where we will use water judicially. Yesterday someone had said water is a commodity. I will like to object. Water is not a commodity, it's a natural resource. It's a precious natural resource. Because it rains every year, we feel it is going to come, it will be there. But no, it's a resource and we need to respect it. So respecting water should be our aim in this conference. Because we are talking about designing today and sustaining tomorrow. If no water, no sustenance. This is the status of surface water. This is falling groundwater over the time. Now, there are quality issues. We have pollution in groundwater. The areas which were not polluted have today become polluted. And clearing groundwater pollution is not easy. So let us have one more motto that we will not contaminate groundwater even if we do rainwater harvesting or we don't do rainwater harvesting. Deeper we go, more is heavy water. This is status of STPs. We talk a lot about STPs, but what is real status? Are they functioning everywhere? And most important, is the water being reused? See, there are many laws which are made that bigger apartments, industrial areas, commercial complexes should have STP. But how many check afterwards whether the water is really being used or not being used? Being in Mumbai Mahanagarpalika, it was my job to visit anything and everything related to water when we feel necessary. And my personal opinion or observation was that the plants are set up. After a few years, they don't run. People say that the societies don't pay. The water that comes in, the STPs, the quality varies, the bacteria die. So sometimes that is directly sent to SWDs. I'm just giving the facts. They are observations, actually seen. So even if we put STPs by making rules and laws, we can't ensure reuse. So why? It is necessary that we properly ensure that our plumbing has separation and there is no mixing, there is no contamination, there is no any threat of any health hazard. Now, in urban infrastructure also, 40% of urban water supply is NRW in most of the cities because of lack of maintenance, theft, leakages. So 40% water is getting wasted. It's a fresh water, which is very precious, which is very limited because of so many reasons which we cannot control. What we can control is what comes in our house, our industry, our establishment. So 135, 150 are the normal figures which are being generally maintained by good cities. This is drinking water standard in India. These are permissible limits. Now I will go to something else. This is designated best use of different quality of waters. Drinking water will obviously come somewhere in A type. But you have B water, C water, D water, E water, which we can use for other purpose. The outdoor bathing, if it is permitted, then at least indoor some activities will be permitted, your gardening will be permitted, your car washing will be permitted. Why use the treated water for all such usages? The pavement washing, that is another point. So we always should have, while we are designing, setting up properties, setting up rules, this always should be the first slide in our mind. Now separation of flows should be at suction level as well as overhead level. Invariably the suction tank is common tank. You get fresh water, we try to put tanker water, you try to put STP waters, everything needs to be separate at suction level or base level. Immediately, accordingly, the pipes have to go separate. The overhead tanks also have to be separate. And the downtake pipes have to be separate. So that by any chance, after the structure is handed over, no one tries to intermix. The threat is that someone constructs, someone stays, someone uses, and someone repairs. So there is every possibility that the connection, there will be interconnection and we will have health hazard. So it is better that we make all the connections properly separated. This is not being actually practiced. It needs to be practiced religiously. Secondly, black and gray water we can very well separate. See, black water has got more COD, it needs heavier treatment. Gray water will have more, black water has more BOD, it will need bacteria-based treatment. And gray water will have more COD, the washing machine water, the wash water. So you can chemically handle it. Chemically handling is more easier than handling the bacteria. So have them separately.
Madam, finish in next 3 minutes.
Yeah, 2 minutes, sir, 2 more slides.
Cool, thank you.
So we use appropriate fittings. See, best waste is your wash basin or your kitchen tap or where people wash. So put a elbow usable tap. So people don't have to close by hand because hands are dirty. It is available. Please use it. This is foot operated tap. Use it. This is another place where more water is wasted because the lady will not sit and get up 10 times. Provide 2-level control. These are very small things. Dual flushing systems, of course, it is common everywhere now. And float ball walls. Extremely essential in overhead tanks. They are not there, the water overflows, the watchman who is supposed to close sees the water and then closes the pump. Sensor-based activities, they sometimes give up and society doesn't bother to change, so water just flows over the ground. Use this. Maybe it can take as high pressure as high as 20 bars. So fittings are available. What we need to do is, the problem is we are not there in picture. The user is not there in picture when the building is constructed. So I thought I should talk here today. There are lawmakers, there might be plumbers. So if this is used, maybe we will save 30-40% of our individual daily used water, whether at home, whether at commercial establishment, or whether in industry. That's all I wanted to say. Thank you.
Thank you very much.
Thank you. Next presentation is by Dr. Dharmaraj Patil, who is Assistant Manager R&D and Innovations, Energy Projects Limited. His subject is hydrodynamic nanocavitation, a cutting edge and revolutionary technology for water and wastewater. Sir.
Good afternoon, everyone. Good afternoon, everyone. Thank you for providing the opportunity to present our work culture and work which we are providing to industry, which is a lab to land. This is our slogan, where we use our nanocavitation technology for the treatment of industrial wastewater, which comes from the pharmaceuticals and chemical industries. Majorly, these waters have high COD and high organic pollutants load. So please. Presentation. Presentation. Oh, yes. No. Yes. So basically today we are presenting the hydrodynamic cavitation technology for the application of wastewater and water treatment. So I am from Energy Project Limited, and as a presenter I am presenting today's presentation on behalf of our MD, Mr. Pradeep Joshi sir. So today's presentation content is what is hydrodynamic cavitation, how it works, what are its benefits on industrial scale, and what is its application, and our case study for lab to land. So in this presentation, basically hydrodynamic cavitation is the technology where water is passed from the venturi at high pressure, and this water is basically when we are creating the nanobubbles during the pressure and passing this water, this enhance the DO level in the water. So basically coarse bubbles and nanobubbles are two things which are majorly considered for the water to enhance the DO. Coarse bubbles are the bubbles which we can see very easily by naked eye, and it is burst on the surface of water. Its residential time in the water is very less, rather than nanobubbles are the bubbles which has high pressure inside its bubble, and it has a high tendency to stay inside the water, which enhance the DO level of that particular water. So in that case, the nanobubbles are stay in the brownish motion, so that they won't come to surface and won't burst very easily. So its retention time in stay time in the water is so high. So this is how it works. It works on the principle of brownish and as well as the brownish motion. So these are the bubble sizes where we can segregate the nanobubble to coarse bubble, where the advantage of nanobubbles which has created from the hydrodynamic nanocavitation technology is that it enhances the DO level in water for a long time. So this is some visuals that I have shown. Here if you see on left hand side, the coarse bubble and micro bubbles are easily burst and on the surface of water, while nanobubbles are stay in the inside the water and enhancing the DO level of that particular water. So how it transfer the oxygen into the water from that bubbles. So basically when we are using surface aerator, fixed aerator, disc diffuser and tube diffusers for the aeration purpose, that has some oxygen transfer up to 2.5 to 7% per meter depth. But in nano cavitation, we have achieved 85% per meter depth of oxygen transfer rate, and this transfer rate is pretty well for industrial point of view, because chemical and pharma industries wastewater has very high COD load, which has different refractory organics, different aromatic aliphatic organic carbons and contaminants. So how to treat this wastewater from the industry very effectively? There are numerous methods. Out of that, one is the advanced oxidation processes. These processes has categorized in two major categories. One is the homogeneous and one is the heterogeneous. What is the difference between heterogeneous? Heterogeneous is the application phase or content of AOP is very different apart from the phase, while in homogeneous, the phase of constituent is very same to aqueous phase. So major drawback of heterogeneous phase is when we are using this application process, in that it is the disposal material will be formed in the heterogeneous photocatalysis, an advanced oxidation process. One more challenge in that oxidation process is to transfer the electron and oxygen holes from the catalyst to material, so which is decrease the efficiency of process, while in homogeneous AOPs there is no need of external chemical or any material to carry over AOP's process. What are the also basic advantages of this method is, it is forming the ROS base, that is the reactive oxygen species. That reactive oxygen species can be formed using the H2O2 peroxide as a strong oxidant, ozone, air, oxygen, with any semiconducting material or photocatalyst material or any ultrasonic waves. So basically these AOPs neutralize and degrade the pollutant like heavy pollutant like phenol, some solvent like DMF and other phthalate, bromides, kind of pollutants which usually emitted from the industries during their operations. So importance of that hydroxide radical is that hydroxide radical has very high oxidation potential, which is number of time high, and it is non-corrosive, so that it won't corrode the system during the process. Like also it has some its stability as well as long time sustainable property for performing the degradation of organic contaminants. In that process, when we are using hydroxyl radical from the any other oxidant, for example H2O2, then that time we need to add the H2O2 in the process for elevate the AOP. But while we are using nano cavitation, that time we are just passing the air from the cavity, our system. So in that time that oxygen from air will form the hydroxyl radicals. It means we don't need to add any further chemicals into that process, where that process will occur for
last 2 minutes, please.
Yes, sir. To perform neutralization of organic contaminants. So this is our hydrodynamic cavitation system, where we use the system with air, pure oxygen and ozone. If industry needs a chlorination, then we can provide also solutions with the chlorination. So what is the benefits of this method? Basically it transfers the 85% of oxygen. More oxygen to microbes will enhance the microorganism BOD and microorganism degradation. And STP plant efficiency will enhance up to 70%. And what it reduces? It reduces the COD and BOD, which is the main problem of industry. So these are the case study where we implement our system into the pharma plant, has capacity of 30 KLD, and specialty chemical plant where the capacity of plant is 20 KLD. So this is the process water before and after. Food processing tank has also you can see the difference between the before and after, and water chemical manufacturing wastewater after the treatment. So this is the textile effluent, step by reduction of the color as well as other parameters with the superoxy system. So it can also use in the agricultural system where we can use superoxide water to plants so it enhances the growth of roots. This is our R&D team. And this is R&D section which we have chemical wet lab, microbiological lab, instrumentation lab, where we assess atomic absorption spectroscopy, gas chromatography, UV spectrophotometer. We have in-house pilot plant having 2 KLD capacity, and other 21 R&D pilot plants also we have. This is our system which we are called as superoxy HNC. Thank you for watching. Any questions? Please.
Now we are open for question answers.
Thank you, Dr. Patil. I now please, may I now call please Anand Jagtap from Mumbai Municipal Corporation. His subject is importance of community engagement in water sector. He has worked many years, about more than 35 years in this sector of building community and community building, how easy it is important to carry out the works that he will going to present.
Forward? Yes. Anand Jagtap. Good afternoon, everybody. I would like to express my sincere thanks to IWWA for providing this opportunity to express our thoughts and our experiences to the larger audience. So I'm going to talk about the importance of a community engagement in water sector. You see, all we are facing the problems are multidimensional. Problems are multidimensional, and we need to seek the answers or multidisciplinary answers for that. Especially water and sanitation are multidimensional. They are not one-dimensional. They are not only technical issues. It is legal, social, and various other human-related issues are involved. So water and sanitation, my experience has been basically in the sanitation sector as well as water sector. So what are we going to discuss about why the water crisis are basically systemic crisis. We can see that India has an 18% total population of the world's population, and we are only 4% of fresh water. Water stretch is driven by the governance, quality, and timing issue. It is not just the availability of the water, but it is also linked with the governance, it is linked with the quality, and it is linked with the timing. Because the timing is very, very important. How much hours you get waters, that is also very essential. 24/7 and other kind of slogans and announcement has not really reached out to the larger audience, especially rural people and even in urban areas, particularly informal settlements. Climate change is another kind of major issue we are facing now for the water crisis. Look at what is the per capita water availability. So we are 2021 figures, like 1,486 cubic meter water and the stress, water stress and water scarcity has been defined below. These are some of the very self-explanatory figures which you all may be aware about it. I'm going quickly. What are natural resources like a crisis? Why there is a water crisis? Natural resources, that is water has been decided as a resource which is scarce, or extraction of the groundwater, pollution, like a pollution, big water pollution. Already we are discussing about the rivers has been polluted, lakes are being polluted, groundwater is polluted. So we are everywhere we are polluting water in form of the grey water and the black water. Climate change is another major challenge for us. Rapid population growth is also another one of the major reasons for the water crisis. And what we talk about the agriculture requirement, because we are going for the cash crops, and cash crops require some more water. So water demand is also increasing in the agriculture sector. So what are the root causes? Just again, it will be repetition, but over extraction of the groundwater, pollution, sewage, industry, agriculture, these are various reasons where we are facing the water crisis. So water and poverty, like our country is a poor country, so we have the poverty is also another major challenge. Water is linked with poverty, because if we want to become a prosperous nation, we need to eradicate poverty. And to eradicate poverty, we require the water, sufficient water for the agriculture, sufficient water for the health, sufficient water for all the human activities. So this is some of the very important component, because water is also linked with the poverty eradication program. And we cannot reduce the poverty or reduce our income inequalities unless we have the sufficient water. What is important, like a water poverty, is not just only availability of the water, but in access to water. That is what we have, like a right to water and sanitation component. Then we have the quality of water, affordability, and reliability. So physical scarcity, infrastructure gaps, and contamination of water are the major challenges in our poverty eradication program, as well as the water crisis. So these issues are combined together when you are dealing with the poverty and water scarcity. Unsafe water consequences, like when we have the unsafe water or polluted water, which results into the communicable diseases. 21% of communicable diseases are formed because of the unsafe water. Waterborne diseases are there very much. We recently have the example of the Indore. You see the Indore, like people were, had the polluted water, and because of polluted water, there was some crisis. Open defecation, we are all dealing with open defecation, open defecation plus, ODF plus, ODF double plus activities. We require the sufficient water. We have constructed around more than 11 crore toilets, but the toilets require the water. So water and sanitation goes hand in hand, but water has been very much discussed. Sanitation is still we have the issues related to water, but we cannot separate these two components easily, water and sanitation. Why we are water scarcity? I will not repeat this thing. You see, why it is important. Our government of India has taken a Jal Shakti mission, project like a Swachh Bharat mission. These are some of the missions which have been taken by the government of India, and we had to implement. So we are all familiar with these activities. I will not go from the very detail. But what I wanted to say, the popular approach, that is top-to-down approach, is not giving the solution. What we require, we need to emphasize on the bottom-to-top approach. That is a community engagement component lies, and we need to talk about a bottom-to-top approach. We need to engage with the communities, and community participation is very, very important component in the water and sanitation. The climate vulnerability, another one, we have the a very, very a funny situation. One time we have the a drought, and so other time we have the flooding kind of situation in India. So we are dealing with two kind of extreme realities. So climate vulnerability is also another very important aspect which you need to deal with when we are talking about the water crisis. And community participation is very, very essential for that. And therefore, Sustainable Development Goal 6, which is talking about the community participation. Community participation targeted under a 6 point, SDG 6. And we need to talk about community participation, and we need to institutionalize the community participation. Why community engagement? Local knowledge and ecological memory is very, very important, because the community are not only like a beneficiaries, but they are also contributing in the knowledge process. They also contribute in ecological memories. So ecological memories needs to be sustained. Ownership needs to be sustained. Like any program, cannot sustain without the community ownership. Community ownership is very, very important. It is not resources are not only by the state, but it is only owned by the community. Equity and inclusion is very important component. And second is the accountability. Accountability comes into the maintenance, because the maintenance cannot be done by the bureaucracy itself. We require the accountability, and accountability lies with the community. Community also needs to be accountable. As a democratic state, we need to have the community accountability, and that can be ensured by the community engagement. Why community engagement is important? I just wanted to highlight very proper examples. You see, operation and maintenance is one of the very important component. What we doing in infrastructure: construct, neglect, and reconstruct. These are a phenomena. We are been lying. It is a syndrome. We are constructing, but again we are neglecting and begin reconstructing. So what we require is the sustainability and design. We are designing for the tomorrow. So what we need to engage the community also in this process, and that is very, very important component for the operation and maintenance. That will give the sustainability. Community engagement for the sustainability is very essential. Sanitation, water linkages, I already spoken about it. I will not repeat this slide. Why infrastructure alone fails? Pipes without ownership leads to leakage and vandalism. Toilets without behavioral change result in ODF replaces. So what is important over here? A community engagement give the guarantee, or it is can lead to the what is sustainability. Second thing, I have worked with the sanitation. I would like to tell you the behavioral change is very, very important. When you're talking about water sustainability or water kind of component, we need to engage the community for the various reasons. Because, for example, contamination of water cannot be dealt without community participation. Centralized planning as well as the local involvement is very important. What is a think globally, act locally is a kind of the slogan which is very popular in the environmental activities. Water systems can be water are basically local in nature. We need to involve the community in the process of the operation and maintenance. Community ownership, I have already mentioned about it, which give the longevity for the sustainability for the project. Local monitoring also very, very important. When leakages and particularly toilets require the monitoring, misuse and waste of resources can be avoided by the community engagement. Institutional models, already we have the water, village level water and sanitation committees, we have the Panchayati Raj, decentralized planning, and we have the various other activities like water literacy. Water literacy program needs to be included into our various programs, and particularly water sector. Indian community-led water models, there are a number of examples of the community examples which are successful. Rajendra Singh's program, Johar Singh, Rajasthan. Then we have the Pani Panchayat in Mumbai. Then we have the not Pani Panchayat, Pani Hakka Samiti in Mumbai, Pani Panchayat in other part of the Maharashtra. So there are a number of examples where the community engagement has been done, and it has given the better result for the sustainability. Benefits of participatory, improve the system performance.
2 minutes.
I will conclude. Reduce the conflict. Many times we have the conflicts in the community, which can we can reduce the conflict. Then we can have the better. What are the key principles? Inclusivity, equity, hybrid knowledge, that is traditional knowledge plus science can be integrated in the community development programs, sustainability and other things. One more component, that is women's participation, also needs to be institutionalized, because they are one of the major players in the process of the conservation and the water, water sustainability. What is being done, I will not repeat this thing. I will go for the current situation. We are all aware about that. I just wanted to, we can reduce the risk. What is important, that community participation also can reduce the risk, and it can safeguard the natural resources. what are the various programs, flagship programs. I just wanted to key takeaways and conclude my session. Community engagement is not optional. It is necessary because many times it is not given importance. It is considered as an optional program. It is central to the water security and sustainable development goal, and India must scale up participatory water governance. And I will say that is, I will end up my presentation. Community participation needs to be institutionalized. It cannot be optional, and for that we need to have the conscious efforts to make the community as a owner of the program, and that will lead to the more sustainability, financial sustainability, social sustainability, and much important, that is the natural resources needs to be conserved for the people, by the people. Thanks.
Thank you very much.
Thank you, Anand Jagtap, sir. Since we have more than about 40 minutes, I request Dr. Pawan Lapshetwar for presenting their lecture. His brief introduction is he is retired as a chief scientist from NIRI. Currently, he is professor of practice department of civil engineering, Indian Institute of Technology, Madras. I request to start. Takle. Yes.
Digital twin. Anshul, can you please help? Yeah, thanks a lot. By the time, thanks a lot. Thanks, Chair and Dr. Vedda, and I would like to thank IWWA to reschedule my presentation. Otherwise, I was supposed to present in the session starting around 4 p.m., but I requested them because I had to travel back to Nagpur. So thanks for the opportunity, and I'd be talking more about digitalizing water system, which of course include both water supply and wastewater treatment, and how Government of India is now proposing that we translate or digitalize our system from physical to digital format. I think it will take another couple of minutes to load the presentation. Yes, sir.
But for the time being, when his presentation is loaded, questions can be asked from our earlier 4 speakers. Anybody to have questions? It looks there is no question from.
So it's there. Should I go ahead with presentation? Okay, so the topic of my presentation is virtualizing urban water system and digital twin implementation for treatment, supply, and wastewater management. My name is Pawan Lapshetwar. Yeah, before I mention that I work at IIT Madras, I would like to mention that I'm associated with IWWA for past 25 years. And with me is Dr. Anshul Yadav, who is an assistant professor from IIT Roorkee. And you know that urban water supply system is becoming more complex day by day. And we, of course, have physical form of it. And if you look at the recently published manual by CPHU on water supply and treatment, they also mentioned that we should now have this digital twin so that we can have preventive O&M. Next slide. Achha, So why do we actually need virtualization of water system? As I mentioned that we are now into rapid urbanization, and which is making our water system that also includes wastewater treatment system also is becoming more complex. We have aging infrastructure. We have been installing this system for years together, and we really don't know that where actually we will have leaks or where will there be any problem. We need to also combat climate variability. There are several examples. In India also, you might have heard increase in turbidity to 8,000 NTU in Bhagirathi Vihar treatment plant in New Delhi in February 2023 because of glacier retreat in Uttarakhand, which affected water treatment plant in Vihar in Delhi. And that treatment plant had to actually close down for 3 days. And you can imagine if you're closing any treatment system, a treatment plant for 3 days, how bad the effect would be. And we now need to make real-time decision. That's why we have this option of virtualizing water system. So why should we have it? Because we now need to predict the real-time behavior of any water system. And it actually uses data collected through sensor. And by virtual simulation, by using this data, by IoT monitoring, we can actually have real-time predictive management. Only thing is that we need to have so much of data through these sensors so that our ML-based models can actually predict behavior of our water supply system. So there's a digital twin evaluation, and the people from our generation, we know about static models. If you go to any conventional water supply division in India, you will find physical models where everything is represented on a model which is kept almost outside the chief engineer's office or engineer-in-chief's office. And these are like physical or static models. We moved to SCADA system. I don't mean that these systems are outdated, but we still use it. But it doesn't give us, say, futuristic options. And when we integrate this SCADA system with IoT, and then apply even AI-enabled twins that can help us to even forecast what will happen to entire water system in any city. So if suppose our water treatment plant is facing some problem, this digital twin can help us in identifying these problems and take some preventive steps so that no problem takes place in the system itself. This is IoT computing architecture, which includes edge computing and cloud computing. So you know that we have to install sensors to determine the behavior of water system, which include flow, pressure in it. At the same time, we also collect data by using sensors related to water quality, such as pH, TDS, and turbidity. So if we are, say, forecasting something at the sensor level itself, then we call it as an edge computing. But when we transmit the data from the sensors to cloud, then we can have even detailed analysis, and that's known as cloud computing. And this is done at the centralized analytics level. And then real-time processing is done at the stage of edge computing. So we have to collect real-time data, for which we need to have IoT, our Internet of Things sensor suite. And there are various suites available through which we can monitor data continuously and in real time. So that this suite includes data related to flow, pressure, and then water level, say in ESRs. And then it also consists data related to pH, turbidity, dissolved oxygen. At the same time, we have to have sensors to even record energy consumption, vibration, and temperature variation, so that it's transmitted through cloud, and then we can do better analytics. And coming back to, say, details of digital twin architecture, we have to have like physical assets that we know. We have physical assets like walls, pipelines, and pumps. So we know, we in fact have physical maps of this, over which we lay a layer of IoT sensor. As I described, there are several sensors available. And we know where actually we need to install these sensors. And these sensors collect the data in real time and transmit. And then we have like data infrastructure in which we assimilate the data. And in the last layer of analytics and visualization, the data collected by these sensors over the entire water systems can be analyzed. So it has like field sensors, and it can, and then we have edge gateway through which the data is transmitted to cloud platform. And then the problem with such system is that we have to have like a very strong cybersecurity layer. We don't want anyone to breach the data security, so we have like 4 such layers which can actually prevent misuse of data. So, it has application. This digital twin has application in, say, various fields, including water treatment plant, but it has maximum application in water supply networks, including this is like distribution system digital twin, in which we can have sensors in entire distribution system, but at critical locations. So we have to optimize location of these critical sensors so that we don't invest much on this formation of digital twin system. So we can digitalize even this entire distribution system. Only issue is that we should know ins and outs of this distribution network. If there is any, say, illegal connections, then that will prevent, say, optimizing this particular digitalization of distribution network, but we can easily do it by using the current state of our distribution network. So this supply network digital, we know that we have reservoir, we have walls, we have different pumps, and then we have cloud platform. So all these sensors, IoT-enabled sensors are installed in these locations of wall, pump, reservoir, and the data collected by these sensors are transmitted to cloud platform where all the data are assimilated and collated. This digital twin also has application in supply management. So we can in fact detect leak detection and then even estimate that how much is NRW. And then we can minimize these leaks by having pressure management. We know now CPHO has recommended that we should have minimum say head of 18 meter. And we don't need that much of head during night time, so we can even minimize these pressure. And we can, by using this digital twin, can forecast demand in future. So that is the application of this digital twin in supply management. Only thing is that we have to integrate with available GIS tools. So we know that these sensors are located in space, and unless we know the coordinates of these sensors, we'll not be able to actually know from where we are collecting the data. So GIS gives us this flexibility of even locating these sensors and transmitting data. And you know that we are well aware of these hydraulic models like IPANET, which we normally use in optimizing our distribution network. And it syncs with GIS tools so that we get real-time data in GIS spatial layer so that we can localize the census also in this. As I told you, digital twin has application in entire water system. That also includes wastewater treatment system. Take the example of treatment and collection network twins. So in this, you know that we have flow of suppose 2,500 meter cube per hour, and we have pH of 7.2, DO is 5.4. So this entire data can be easily transmitted, and we can, I think we started even developing the system. Professor Sadgir, he's now employed such sensors in Pune for 100 KLD plant. So I think we are getting so many cases, use cases in India also. This is an example of treatment plant digital twin. It's much easier for us to do it for like system like water treatment plant. So it gives us the data like flow rate, pH level, turbidity, chlorine. And in case if we feel that there is a variation in, say, raw water quality, in such cases, the model itself will fine-tune, and the doses of, say, coagulants will be automatically adjusted so that we get the treated water having turbidity less than 1 NTU. So this is the benefit of, say, having a digital twin of, say, treatment plant, so that we reduce energy at the same time, we optimize even chemical dose. And in such cases, it becomes really for us to have cost-effective treatment. And this is how this works. So as I mentioned earlier, that we can optimize chemical dosing because we like precise measurement of optimal chemical uses. We know that we should not use a high level of PAC. Otherwise, it will increase the concentration of aluminum in treated water. And that's why we can even control dosing based on the inlet turbidity. Secondly, as I mentioned, and if any wastewater treatment plant, if the DO is fairly high, in that case, the aerator can easily be stopped, and it will in fact save a lot of energy also. And this helps in fault detection as well. And as this digital twin is used for optimizing water distribution network, similarly, it also can be used for sewer network design twin. The benefit of it is that it can be done in operating condition. And see, suppose we are like overflow prediction point, and it can help us in identify where can the leak be. And now there is an additional benefit of using digital twin in case of in fecal sludge management as well. So we are like closing the cycle in terms of not only water, but we are integrating it with sewage treatment and even fecal sludge treatment also. There are advanced capabilities. So we know that we can collect such data by using this sensor, and the data can easily be transmitted to the cloud. But how can this data be used in futuristic prediction? So we are using artificial intelligence and then machine learning software through which we can determine the behavior. Only concern with this is that we need to have so much of data so that we can fine-tune this AI and ML models, and it can give us the proper results of future operations. So this machine learning integration can help us in predictive or preventive maintenance. It can even detect anomalies in the system, and we can have, say, soft sensors also. We don't have to have like physical sensors. We can even forecast what will be the, say, turbidity level at the end of treatment if we have like digital twin. Yeah, but these ML and AI tools are data thirsty. We have to have so much of data so that the predictive models are optimized and they give accurate results. So I'll just. So this is like digital twin is a decision support system because it gives real-time metrics. It can provide us the data that how much is the like system load, how much like throughput, how much like system input. So it can even give us the alert notification because it's sensor-based. So suppose if you want to predict what will happen in Aurangabad water treatment system day after, and if we have like Pakka digital twin model available for entire water system in Aurangabad or Sambhajinagar, in that case, if there is any change in inlet water quality, or even if there is a, say, we have detected leak in any system, so that can give us trigger that what part of Aurangabad city will be affected. I'll close with a few case examples. So this is like treatment plant digital twin. There's intake. If it is like turbidity of 2.1 NTU, and we know that how much should be the dosing of coagulant, it of course depends on pH and alkalinity. And it gives us what will be the inlet turbidity to filtration unit, and how much of dosing of chlorine should be done. That also can be determined or decided. And then if you properly integrate it with automation, then it can help us even dosing these much of chlorine and PAC. And as I told you, there are use cases available all over the world. We are now developing these digital twins in India for several such places. So myself and Dr. Anshul Yadav, we have proposed to do it in Noida. Yeah. So yeah, it's very easy to say that, okay, we can develop digital twin, but our systems are very complex. And there are some implementation challenges. One of them is sensor reliability. We are not having many indigenous sensors. We have to rely on other countries to have these sensors. See, even chlorine sensors also, we rely on, say, ORB type of sensor, which indirectly predicts that how much is the chlorine. So sensor reliability is a much bigger issue than we think. And secondly, the sensor quality and the performance degrades over time. So when you have like reliable sensor, there are data gaps also. As I told you, we really don't know about our distribution system. There might be some illegal connection, there might be leaks also. So unless we have reliable data, it's very difficult to develop such a digital twin. And high initial cost. We have to like sensors installed at different places. Cost of the sensor and all those adds to higher initial cost. But once we install it, I think payback period may be around 5-6 years. Dr. Sadgi told that in his case, it's only 1 year. So we can optimize and bring down this payback period also. Yeah, how should we do it? But like we have to have like self-learning system. We have to start with the like smaller system where we can install, we can have like digital twin. We can integrate it with smart city, and once we do it, and we can begin with smaller cities and have like autonomous operation of these systems instead of relying on a huge manpower, and we can optimize. So the key takeaway from this presentation is a digital twin can enable smart management, say, across entire water system, which of course include wastewater treatment and fecal sludge treatment also. IoT powers virtualization. We are just translating entire physical assets in virtual or digitalized form, and that helps us in developing preventive management and maintenance. And this can be pathway to sustainable cities. So thanks a lot for your patience and thanks.
Thank you very much.
Yeah, thanks for giving me a opportunity.
Can you name some town in India? Can you name any town in India where it is proposed even? I mean, I don't think it exists anywhere in India.
Yeah, it doesn't exist.
So has anybody taken an initiative to start this work on this particular project?
We proposed to do it in Noida. And we have submitted a proposal to CPHU, and if they feel that this can be implemented, then we'll take it forward. But we are in initial discussion with the Noida municipality, and world over it's now happening. They're preparing digital twin of say entire system, and then try to.
I think if it starts with a water treatment plant or a sewage treatment plant, it is practicable.
Yeah.
To extend it to the whole town.
Yeah.
I think it is going to take long time and very heavy investment.
Yeah, you're very correct. So that's why we should begin with smaller systems like wastewater treatment plant or wastewater treatment plant. Then if we feel that it's really successful in preventing some mishaps in these plants, then we can definitely go ahead with water supply. So it's challenging for sure.
Thank you very much.
Thank you. The presentation which could not be done earlier session, Pratik Srivastava.
Hello everyone, I am Pratik Srivastava, representing my company that I'm working for, Kirloskar Brothers Limited, a global leader in the fluid management systems. So, okay. It's not working. So we are a world-class pump manufacturing company with expertise in engineering and manufacturing of fluid management systems. Kirloskar Brothers Limited is the mother company of the $2.5 billion Kirloskar Group. We are particularly manufacturing pumps, industrial pumps, and hydro turbines and valves. We are certified with ISO certification, and we have 14 manufacturing facilities across the globe, out of which 5 are outside of India. So I will be focusing majorly upon the pump as turbine product of ours, which is a turbine which works on the principle of Francis turbine. So dignitaries within the water networks that we manage, flowing under our feet, is a vast, invisible, clean source of energy. We spend significant through which we can take out significant energy through the excess pressure. So the technology to do this is not new, complex, or prohibitively expensive. In fact, it is a brilliant example of circular economy in engineering, using a standard readily available pump working in reverse mode known as PAT, pump as turbine. So this is a diagram in which firstly how a pump works. So if I see in the diagram, you can see the upper part is called as the delivery, and the horizontal one is known as suction, which is a significant which is a simple pump. But in pump as turbine,
excuse me, can you please tell what you are going to say? What is the objective of this presentation?
This is commercial.
क्या बताना चाहते हैं?
Commercial presentation on pump as turbine.
Pump as a turbine?
Yes, sir.
Okay.
Okay, so this horizontal. So in pump as turbine, the suction becomes the delivery, and the delivery becomes the suction. So here we harness fluid energy with the pressure difference, and subsequently generate power. So why to choose PAT system? First of all, the first advantage being the initial upfront cost, since it is a standardized pump. So it can be. So we just have to reverse the delivery point, like delivery points. So that's how it is cost effective, and the direct drive of machinery generates electricity in parallel to a large grid or isolated. Or combination of these is possible just with a conventional turbine. And this is an off-the-shelf product, so the delivery time is very less, and the maintenance is almost nil because because the operation is very simple, and all the parts that are required in the maintenance operations can be taken from the pump dealers. The spares are also very easily available, and the factory test of the system is done before we deliver the product. So now the solution range of PAT at our facility is from 0.5 kilowatt to 800 kilowatt, both in off-grid operation and on-grid operation. So we are offering. So this picture is for the Pico turbine, which is a solution for up to 5 kilowatt of energy. So this can be utilized in the off-grid operations, where the electricity generation through electricity rendering through the grid is not possible. And for the rural and remote installations, we have already created testimonial for this. So I'll just go to the selective applications. So at KVL, with our deep legacy in pumping solutions and hydro turbines, we have pioneered the practical application and performance mapping of PAT systems. So the first one being the dam water supply. Environmental water which is released from the dam water. So we had installed and commissioned one PAT unit at Tansa Dam near Mumbai, where we are generating 40 kilowatt of power, 40 kilowatt hour power in off-grid operation, which is sufficient, which is sufficing the energy need of the entire power station of water resource department at Tansa Dam. Second being open water streams at remote locations. So we were able to install PICO and PAT systems in Kerala district, particularly with Kerala Forest Development Corporation. There we had installed few PAT systems of 5 kilowatt capacity and 11 kilowatt capacity. The next big industry application, where we can harness the fluid power through by replacing pressure reducing valves. So we had done one installation at JNFC Bharuch, where we had installed a PAT system of 22 kilowatt in off-grid operation. The last one being intake water pressure at water treatment plants. So this we had done in Hong Kong, where we had installed 65 kilowatt of PAT system, which has been running since 2014. So next slide, please. Next slide. So these are a few references. We have installed a product in Kerala, Maharashtra, Gujarat, at overseas in Hong Kong, Shimla, in Pune, and in Mankulam. Now coming to, I'll just walk you through the video. Could you please run?
Lights from water. Across India, there are many such places which are located in hilly and remote areas amid dense forests and are hard to access. Also, these places mostly have a source of free-flowing mountain water available. While the state power utility does provide electricity connection to these places by laying an overhead cable through the forest, but the power supply is erratic at best. This problem was taken up as a challenge by the engineers of Kirloskar Brothers Limited and created this pump wonder in the form of PICO. A mini hydro power generator was created. A mini hydro generator which can generate electricity from free-flowing mountain water. This tiny and remote village near Pune in Maharashtra, about 25 odd houses, now gets its alternative power from free-flowing mountain water for the 5 to 6 monsoon months from PICO installed for them. When the power supply breaks down frequently, it takes 10 to 15 days for the staff to repair the lines and restore the supply. The situation is worst during monsoons, as this area receives heavy rains and the overhead cables get damaged, plunging the entire village into darkness. He constructed a small bund and a powerhouse to set up a line on poles and brought the electricity to this village. A storage tank has been built to collect the flowing water from a local downhill stream, which is ferried through a 6-inch pipeline to a power station 50 feet above the tank. The high water pressure is used to run the PICO turbine, which generates electricity and reaches the village via a 800-meter cable. These lights from water has solved the problems of locals. Said a village local, adding the uninterrupted power supply was crucial to keep villagers safe in the night, especially from snakes and scorpions. Another such example of ingenious use of PICO is Ashwani Khad, a beautiful hidden place known for its waterfall and pristine nature. It is located 15 kilometers from Solan. Accessible via a slender road through the mountains, it's a source of drinking water to the city of Shimla and has a water treatment plant which treats the mountain water for its use as drinking water located in the vicinity. The mountain water is collected and is fed to this water treatment plant via pipes. But before treatment, the mountain water pressure has to be reduced with a pressure reducing valve before going into the treatment plant. A PICO unit is now placed in between, which not only reduces the pressure but also generates the electricity free of charge, which is used to illuminate the water treatment plant and its vicinity. Kirloskar Brothers Limited, with its PICO and PAT products, is now helping many such villages for rural illumination, remote tourist locations,
coffee plantations,
remote defense camp requirements, etc. across India to get uninterrupted supply of electricity using free-flowing source of water. Please do call us on 1-800-1234-443 or write to us on marketing@kbl.co.in or log into our website for further information.
Thank you, Pradeep.
So with this, I'll conclude the talk. Thank you very much.
Can you please answer one question?
Yeah.
You tell it is a pump as a turbine.
Yeah.
So why not only a turbine? You are only using as a turbine. So why pump as a turbine?
So we came up with the solution because the upfront cost for a turbine to generate, X amount of power would be much higher. And with this product, we could, like the investment goes too low. So that is one.
But question is, if you design a turbine in this particular shape, why you call it a pump? You say it is a Francis turbine.
It works on the principle of Francis turbine. Yeah.
Okay.
Yeah.
So for a Francis turbine, it is a turbine plus a generator. So what is the difference between the two? I mean, the logic, except a commercial nomenclature, to nominate it as a pump as a turbine, it is a turbine generator only.
It's a generator, sir. Yeah.
Thank you.
Thank you. Rajendra Ganatra sir has one crucial point to say, and it was not said, left behind. So I request him for 5-10 minutes.
Thank you very much, Mr. Vaidya and chairman of this panel. I was continuing and I thought that a point should have been emphasized. It was truncated. So as I was saying, the whole idea of a viable project is that the value should exceed the cost. Now what happens in the private sector? Everyone identifies a business which has potentially very good value and a lower cost. So they work hard with the feasibility study and eventually figure out what the value is. For example, let's say when I joined top management in a large corporate company. I handled project financing and I got a proposal where the cost of the project was 2,000 crore. Its value was significantly more than 2,000 crore, right? So the cost was 2,000 crore and I raised a finance of 1,200 crore of loan. The remaining 800 crore was going to be the equity, that is debt to equity ratio 1.5:1. But you'll be shocked to know that the real cost of the project was only 800 crore, less than that. So it was padded by 2.5 times. Because the person had an idea of the value, he padded it So what he did was he extracted entire equity of his from the value, and it was funded entirely by the debt. Now what am I trying to say with this? What I am trying to say is that if the value, if the competitive bidding happens, only then somebody is going to keep a reasonable margin. Otherwise, he's going to pad the cost and you'll be able to do nothing about it. So therefore, this, the water, the authorities, for this very, crucial golden public good, must have systems. I'm not saying you do PPP or any other model. We see in Singapore, they have PUB, which has, created PPPs. Yesterday we saw PBA of Malaysia. It's not a PPP. It has one PPP under its ownership, but there are 8 plants under its own, and its equity is valuable. They operate profitably while giving value to of the money to the people. Can't India do it? India can do it. We have to work out, and it's doable. I'm going to write about it. It's doable, and I have written a number of articles on various subjects related to financing. I have given solutions, and some have been implemented as well. I have seen those getting implemented. What I am saying is that let's focus on minimizing the cost by having best of the feasibility studies. Will not cut cost on that. Cutting cost on feasibility is no good. Then you get trash. The moment you get trash, you are, designed to fail. We're not going to design to fail. Go for the best feasibility, don't adopt L1. Then qualify the best of the people and then let them compete, and make sure that you are adding value by mitigating your risk in your domain, and you can do it. It can be anything. Another thing is, we have so many engineers, so many innovative companies coming up with solutions which are in pieces. Now somebody has to combine these pieces and come up with a formulation so that you can come up with integrated end-to-end EPC for this. You don't need outside fellows. A technology company coming in the garb of a developer and running it. Now that's unbelievable. Yes, we have to do something about developing technology. Maybe the government has to set up some kind of a water, technology fund for that. We still have a gap to fill in. But then, operator is different from a technology company. If technology company is coming as a strategic investor, then let it add value by way of a technology. We are all aware that those technology companies or that technology company which has come in here as developer has not really added anything by way of the technology. So my point will be that when we are coming up with, cost, let's minimize it so that the bidder, can come up with a reasonable margin. And the moment you have minimized the cost, you are also going to, retain a reasonable value which gives return on the capital employed of the government as well as the developer, while delivering value to the consumers. Last, just one more minute. When the moment we are talking of financial viability, we are talking of the value exceeding the cost. But where in a crucial water, initially it's not going to happen this way, it's going to take time. Meanwhile, government will have to subsidize, but going forward, you can replicate or even emulate the PBA which we heard yesterday. Thank you very much. I'll always be available to give any advice on this pro bono. This has been, I don't have need for anything further, so I'll always be available and we can definitely work out. And thanks for inviting to this grand conference. Yesterday I had a talk with Dr. Prasad Modak also, and we're going to do something about it. Thank you very much.
Thank you all presenters. May I request to give mementos? Sir, Goel sir, mementos. Thank you. प्रतीक 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 श्रीवास्तव. All delegates are, there is a one. There is a one book display is there outside our hall. Kanchan recipes, Kanchan Bapat recipes. Many interesting recipes are there, and you can visit the stall just outside this hall. And we will assemble here again at 2:30 after having a lunch. Thank you.
Yeah, one small announcement. Maharashtra state is known for the forts. A display of Maharashtra's fort has been kept all around the hall on the sides. Our script written in English and Marathi. So enrich your knowledge about Maharashtra fort also. Thank you. Presentation is scheduled in next session. Kindly contact the IT section and download their presentation to avoid the last minute hiccups while you are presenting it. तुमचं झालं केलं.
Shiva.
शिव कैलाशों के बसी धौलीदारों के राजा शंकर संकट हरणा। शिव कैलाशों के बसी धौलीदारों के राजा शंकर संकट हरणा। तेरे कैलाशों का अंत न पाया, तेरे कैलाशों का अंत न पाया, अंत
Good afternoon, delegates. Let us start our next session, session number 3. I request Qureshi sir to chair the session. Qureshi sir, please. तुमचं एक कोणी कमर्शियलचं आहे का? Hello. I request Colonel Bhaskar Tatvavadi to come on the dais and Dr. Parag Sadgir. Delegates, our session number 3 is on wastewater recycling and solid waste management. And first lecture is on promotion of treated wastewater recycling. Few case studies. The lecture will be given by Colonel Bhaskar Tatvavadi. He is Director Double Shots Private Limited, and we read him in articles many times, and it is his specialized subject. I request sir to please come on the podium and present.
Good afternoon, everybody. Am I audible? Okay. Thank you. The presentation which I am going to make is on promotion of treated wastewater recycling, a few case studies. I did my civil engineering in 1974, did my master's in environmental engineering in 1984. I have worked in the Indian Army Corps of Engineers and later as a consultant in water and wastewater management. For the last over 2 decades, I have been working in the treated water reuse, and it is a subject which is very close to my heart, more so in today's context because that is the only remedy to overcome the water scarcity which we have all over the world. I chair the American Society of Civil Engineers Environmental Water Resources Institute Committee on Desalination and Water Reuse, and also its Water Reuse Task Committee. I want to structure my presentation first by talking about the compulsions for recycling, the regulatory environment which we have, under which we have to operate, water recycling state policies, their limitations, shortcomings, policy and practice disconnect. Though we have policies, in practice there is a lot of gap. So there is a disconnect, and how we can overcome this way forward. I will talk about a few case studies with which I have been associated. Okay, this context setting has been discussed since yesterday number of times. So our population is 1.46 billion, out of which urban population is close to 55 or 550 million. And urban wastewater generation is 80,000 million liters per day. Treatment capacity is only 27,000, about 30%. And actual wastewater treated to some arbitrary levels is just under 20,000 million liters per day. So In addition to that, we have in our country water-stressed areas. About 75% of the geographical configuration of India. And by 2050, the Niti Aayog expects that this area will increase to about 90%, which should ring alarm bells across the water fraternity. We have cities with population of 5 to 10 lakhs which consume over 100 million liters of water every day, about 200 in number. And out of these cities, only a few cities are recycling water in some quantity. These cities include Mumbai, Nagpur, Chennai, Surat, and Navi Mumbai has recently started their water recycling plant. These are some of the numbers which I was able to get from the Council of Energy and Environment journal. They talk about the market value of treated water. So they want to make a business case for treated water reuse. They say that the at current prices, there is a market of 8.35 billion US dollars. And by 2047, they expect the market to grow to $8.35 billion. Then there is the usual description about how many jobs it will create, etc., etc. The capital cost for treating the water or the wastewater by 2047 is approximately 18 to 27 billion US dollars. And this is the investment required to reach the national target of 100% used water treatment. Now, who has given this target of 100%? I am not aware, but they have calculated some numbers, and they say that this much investment is required. Now, when we talk about the agencies which are involved in this mammoth effort, first of all, it is the Government of India through its Ministry of Environmental, Forests and Climate Change, Ministry of Jal Shakti, NMCG, CPHEEO and the Ministry of Housing and Urban Affairs, CPCB, the National Green Tribunal, which is a spoiler, the state governments, state ministries of water resources and urban development, rural development, state pollution control boards, and urban local bodies, finally. And here the discussion is about the urban recycling of treated used water. So I will restrict myself to the urban sector only. The Water Act, we are all aware, was enacted in 1974. CPHEO published its Manual on Sewerage and Sewage Treatment, its second or third edition in 2013. And in this edition, for the first time, they mentioned reuse of treated wastewater. And they had given a table in which they said that the wastewater should be treated to particular levels for specific reuse applications. By 2017, about 17 states of the Indian Union had published their treated water reuse policies based on different criteria, which was, means they had their own logic and reasoning for the criteria prescribed and the reuse applications also. In 2019, the National Green Tribunal intervened and prescribed a uniform set of discharge standards for all the urban local bodies, regardless of their population and regardless of their financial status. And this created a big sort of earthquake in the existing ecosystem. It caused confusions, problems for the existing and operating wastewater utilities because the overnight application of upgraded standards was not possible. Okay, very recently the CPCB has further aggravated this problem by publishing its discharge standards in 2025. I think this happened in November or December last year, and they have linked it to a new regulation which was drafted and published through a gazette in 2024. It is called the Liquid Waste Management Rules 2024. Now, this is all happening in the backdrop of chronic and acute water scarcity. And this scarcity is the driver for treated water recycling. But the lack of correlation in municipal water production, its cost, and the fact that it is in no way related to the tariff which is levied on the consumers, these are the big challenges. Here is a definition of water scarcity, which is there for you to see. The point at which the aggregate impact of all users impinges on the supply or quality of water under prevailing institutional arrangements to the extent that the demand by all sectors, including the environment, cannot be satisfied fully. And this is true for most of the cities in India today. About 600 million people face water scarcity in India. This is about 45% of the population. About 200,000 die due to lack of access to safe drinking water. What happened in Indore is a recent case, but this is the estimation of a few researchers who have done work in this area. By 2030, the demand for water will be twice the available supply. And our entire planning is supply driven. We do not focus on the demand and demand management. A water poverty index study of 11 states in India has indicated that the situation is extremely alarming. So this brings me to the requirement for the treated water recycling and the growing scarcity of water resources, contamination, urbanization, population growth. All these have been discussed in this convention. Climate change induced erratic rainfall pattern, reduction in pollution of water bodies, promotion of circularity in water use. What is happening, unfortunately, in our country is that the regulatory bodies, they work in jerks. So one day you get some kind of a document related to circularity. The next day you get some things related to sustainability. But a comprehensive document which takes care of all the facets of water governance and management is unfortunately not yet available. The sustainable approach to water conservation, energy production, agricultural productivity, these all demand that we immediately start recycling water. Increase in supply of water for drinking for urban and rural population. If we are able to recycle water and reduce our dependence on the existing sources, obviously we are going to make more water available at the source, and that will improve the sustainability. A document known as the National Framework for Safe Reuse of Treated Water was published by the National Mission for Clean Ganga, NMCG, under the Ministry of Jal Shakti. But this is a recommendatory document. It does not bind any of the states, any of the ULBs, any of the agencies into time-bound programs for treated water reuse. It does not mandate the standards which are needed for different reuse categories, and therefore what it appears to be is a half-hearted attempt at providing some kind of solution, but it is neither binding on the states nor there is an enforcement agency created to ensure that water recycling will happen as per a time-bound program. So what happens is when the international agencies like the World Bank, they start talking about circularity. You see, we are very good at developing jargon. Now there is water circularity in the water sector, and there are many publications, many research articles, papers, which talk about the circularity in water. And what happens is, once the international agencies, they start talking about a particular point, then everybody picks it up and then goes about talking about the same thing, and they keep recycling those terms and terminologies without thinking about the context in which we are operating, the kind of work system we have, the governance system which we have in our country. So that is one of the problems. But anyhow, our government also published guidelines for reuse of treated sewage in reference to the item of circular economy. This was a CPCB publication in 2024. Thereafter, there has been no movement in this direction. Yesterday, also there was some discussion about the circularity in water use. Instead of a linear pattern where we use water, gets converted to wastewater and goes into the environment, that at least a part of it can be recirculated through treatment, can be used for different applications, and that is how we bring in circularity in water use. These are the enforcement gaps in state policies. I told you that about 17 states had published their policies for treated water reuse. And just, I think, last week, or 2-3 days ago, I was reading that Uttar Pradesh has now embarked on a very, very ambitious program of recirculating 100% of wastewater by 2030, considering that there is hardly any notable example of treated water use in Uttar Pradesh today. I have my doubts about how they are going to achieve this in the next 4 years, but that is how we seem to be working in water sector. Very few policies prioritize sectors for recycling. Most policies make only recommendations on technologies. They don't give many details. They do not consider allocation principles for treated wastewater, how it is to be allocated for which uses. There can be an allocation for the construction sector. There can be an allocation for the horticulture, agriculture. There is no discussion on that. Most policies also do not define binding provisions to aid effective implementation, and this is the biggest problem. So here I want to just show an example, a case study which is very useful, how the United States has gone about developing an ecosystem for treated water recycling. Okay, the first guidelines for treated wastewater reuse in the United States were published in 1980. That is the that is the box at the right side bottom. Thereafter, after 12 years, the second set of guidelines was published in 1992, which took care of some of the deficiencies in the 1980 guidelines. The third set of the guidelines was published in 2004. And in this 2004, there was a discussion about possibility of direct potable reuse. That is, to treat water to a level where it can be directly used for drinking. The next set came in 2012 with explicit guidelines for direct potable reuse applications. In 2015, a framework for direct potable reuse was published, and these frameworks are binding across all the states in the United States. Not to talk about Canada, which Donald Trump wants to be the 51st state. 2016, a potable reuse research compilation was published. 2017, potable reuse compendium was published. So successively, they have gone about doing their research, case studies, scientific research, methodologies, processes, and technology evaluations, and all these have been compiled successively. Not stopping there, mainstreaming potable water reuse is another document which was published in 2018. 2019, US EPA published draft water reuse action plan for the entire country. 2023, water recycling for climate resilience through extended aquifer recharge was published. And recently, risk-based framework for developing microbial treatment targets for water reuse were published. Now, this is how, over the last 45 years, a country has progressed from zero water reuse to direct potable reuse. In other countries, like the European Union, Mediterranean, and even in down under in Australia, most of the regulators have taken help and have been guided by the United States EPA water reuse guidelines, and they have published their own guidelines, processes, and publications. The European Union has gone a step ahead of the United States in that they have mandated that all the towns by 2045 will have not just primary, secondary, tertiary treatment, but also quaternary treatment. That is going beyond the membrane processes and polishing further the effluent that will be created after the primary, secondary, and tertiary treatment. Yeah. There has been a lot of discussion on what is ailing the Indian water sector, and the same thing applies to the wastewater sector also. So I don't want to dwell on this too much, but only suffice it to say that while we are not able to provide adequate and safe water to our citizens, there is a discussion and a misplaced priority on projects which use the available kitty for projects like 24/7, where water is just not available to the citizens even for 2 to 3 hours per day. So as I told you, the Nagpur Municipal Corporation, Mumbai, Chennai, Surat Municipal Corporation, these have municipal wastewater case studies, and there is a seawater desalination case study of Chennai, which is there just for the comparison of cost comparison. These are some details of the Nagpur Corporation treated water reuse plant. 480 MLD ultimate capacity. It is operated by Nagpur Wastewater Management Limited. A 35 MLD sewage treatment plant at RCF Bombay. Yesterday, Dr. Prasad Modak, he spoke about the Rashtriya Chemicals and Fertilizers plant in Mumbai. That was a 23 MLD plant. Another plant, and that was based on primary, secondary, tertiary treatment of wastewater, which is purchased from the Bombay Municipal Corporation. So when the second phase of this project came up, I designed a plant which uses only primary screening followed by membrane processes, that is ultrafiltration, followed by brackish water reverse osmosis. And this plant was commissioned in 2019, and it is giving excellent results. Chennai has got their wastewater treatment plant in Coimbatore. It is capable of producing about 75 million liters per day. At present, producing just about 40-45 million liters per day. Probably there is some problem with the demand. These are some photographs of the Nemelli 100 MLD seawater desalination plant in Chennai. And here are some municipal water production costs to give you a context of what we are talking about. Pimpri Chinchwad, Navi Mumbai, Shahad, Temghar, the water production cost is about 8.5 rupees. Nashik, Pune, about 10 rupees. This is for 1 kiloliter. Pune 10, Kolhapur 12, Nagpur 16, Mumbai 19.44, Bangalore and Chennai 40 rupees per kiloliter. Bangalore and Chennai, to me it seems, are having under priced. Coming to brackish water treatment cost, these are the some of the plants which I have taken from several references, and the operating cost per kiloliter is in US dollars. It ranges from 0.29, that is 29 cents, to 86 cents. Seawater desalination cost, again per kiloliter cost, it ranges from 51 cents per kiloliter to $1.9 per kiloliter. So here I come to some of the conclusions. My conclusions are that, first of all, our water supply tariffs are not related to the water production cost. So although the water production cost is very high, the consumers do not pay for the full cost incurred for water production. And thereby we have a problem, because the cost of the brackish water treatment or seawater reverse osmosis is very high, but even that water, after spending $1.50 per kiloliter for production, is supplied below 10 cents to the consumer. So we have a problem that all our projects are top-driven. There is no effort at public engagement, and there was in the morning session a good discussion about how public engagement is important. And for all wastewater recycling projects, public acceptance is 100% necessary, and if we are able to achieve that through various means, then only our treated water recycling projects will be successful. If we are not able to achieve that public acceptance, any number of regulations, any number of documents, any number of acts which are there, because of the lack of enforcement and lack of public participation in the development of these projects, we are going to have difficult times ahead. But I am not a pessimist, I am an optimist, and I believe that public acceptance and transparency in dealing with public while developing the project, during the procurement process, and thereafter during the operation and maintenance phase of the project is very necessary. And if we can achieve that, we will have our jobs made easy. To all my colleagues here dealing in water management and governance, I wish you all the best. I thank IWWA India for giving me this opportunity to share my views on treated water recycling. Thank you very much.
Thank you, Colonel. There is a next lecture of Anand Jagtap, which was earlier. One more lecture. So in the last session, there are only 2 lectures. So I am continuing this instead of taking tea break and again coming back. So the title is Portable Biotech Toilet, Promising Solutions. IoT-based decentralized wastewater treatment system. Dr. Parag Satgir, Dean of College of Engineering, Pune, and Professor, will give the lecture on this IoT-based technology. Sir.
Good afternoon to all. My topic of today's presentation is IoT-based decentralized wastewater treatment. As the sir has told that there is necessity for reuse of the wastewater, and depending on the municipal corporations or the government bodies, instead of that, if we start from the source of the water, then it is easy for us to solve this particular problem and as early as possible. Because the rapid urbanization leading to the increased wastewater generation and the overloaded centralized sewage treatment plants, high cost of the sewage transport and pumping, as our urban areas are increasing, the transportation cost of the sewage is increasing because the STP is located at some further places. Due to that, the cost of the transportation increases. So need for the sustainable, local and the smart wastewater management is the need of the hour. So we are proposing these particular decentralized, it is already there from the long time. So small scale STPs located near the wastewater sources treat sewage at housing society or the cluster level. So it reduces the load on the municipal sewer networks and it enables the local reuse of the treated water. So this treated wastewater we are able to use for the flushing purpose as well as for the gardening purpose. So approximately 30 to 40 liter from 100 to 135 liter requirement of the water is reduced due to these particular, if we make the compulsion for these treated use of the treated wastewater. So if you see the worldwide scenario, the growing global shift toward the decentralized wastewater treatment, as sir has also mentioned in his PPTs, so it is driven by the urban densities, water scarcity, and the sustainability goal. And there is strong integration of the IoT, AI, and digital twins, as Pawan Lapshetwar sir has mentioned in his presentation. And it is aligned with the UN's SDG 6, that is clean water and the sanitation. So if we talk about the Europe smart and the green wastewater systems, so Germany, Netherlands, Sweden leading the decentralized STPs, they are following the strict EU water frameworks guidelines for that particular. And IoT they are started using for the energy optimization and the nutrient recovery. So high reuse of the treated water for the landscaping as well as the industry. So when we goes to the United States, they are started with the community level STPs. So decentralized systems is common in the suburbs and the rural areas. And the US APA is promoting the smart water infrastructures. So IoT-based remote monitoring for compliance is also in increase. So public-private partnership is widely adopted. The Japan and the South, they are advanced automation. So compact decentralized STPs for the high density urban housing, they are promoting. Extensive use of the sensors, robotics, and AI control. So real-time fault prediction and maintenance, so it is causing the effective use of the reuse of the treated wastewater and high standard for the treated water reuse. In the Singapore, they are any water program for is the benchmark for the reuse. Decentralized and the centralized hybrid approach they are following. IoT-based end-to-end monitoring they are doing. And treated wastewater is used for the non-potable as well as for the industrial purpose. So when we come for the developing countries, China, Brazil, South Africa adopting for the decentralized STPs, and they are focusing on the cost-effective modular systems and mobile-based IoT dashboards. So government is also leading smart city initiatives. So after key look, if we see from the global learnings for India, mandatory digital monitoring improves the compliance, energy efficient aeration and automation reduces the OPEX cost, and water reuse is critical for the urban sustainability, and municipal command center enables scale and the transparency. So study is required because major housing societies that installs the decentralized STPs, but they are non-functionals. That is the reality in the various states of the India. Non-availability of the skilled personals for the operation and maintenance of the STPs, and operational problem during the functioning, high maintenance cost, energy consumption, and its cost. So we have studied near the Pune, one city, in which we have found out that 54% STPs are functional and remaining 47, that is 32 plus 24% are non-functional. So reason for that is direct connection to the municipal sewer lines, non-affordable cost of the electricity, foul smell during the functioning, and sound level exceeds permissible limit. So the society residents are blaming to close down that particular units, and they are causing the foul smell during the functioning. So non-availability of the skilled laborers, non-availability of the failed components, and improper guidance to the housing societies. So at present, in the 2024, when we have carried out this survey, there is total 2003 are functional and 101 are non-functional DST. So the municipal corporation has taken the measure for that particular also. And impact of the non-operational STP is utilization of the potable water for the non-potable activity, and which is increasing the demand of the water for that particular city. Additional load on the municipal STPs, which increase in the financial burden. It increases the water pollution of and causing the pollution in the rivers as well as the reservoirs. Scarcity of the water increases the water body pollution. So typical treatment process, as we are providing regularly, that is the main chamber for the decentralized STPs, we are providing the main chamber that is included in the coarse grain, oil and grease chamber. After that, we are providing the collection or the equalization tank, and we are using the moving bioreactor, that is the MBBR, and it is followed by the tube settler. Then we are collecting that clear water tank, which is followed for the tertiary treatment, that is pressure sand filter and the activated carbon filter, and either ozonation or the chlorination or the UV, depending on the society's requirement. And then the treated water tank is provided, from where the water goes for the flushing as well as the gardening purpose. So what is the role of the IoT in these particular DSTP? So real-time monitoring of the treatment process, remote supervision by the municipal corporations as well as the municipal MPCB, automation of the plant operations, and early fault detection and the alerts. So it will provide you the 24/7 monitoring, uninterrupted real-time data, as well as the smooth working. It avoids man-made mistakes and gives the early problem detections. It reduces the electricity for operation and maintenance, because if we optimize the aeration, the cost of the electricity is, energy consumption is reduced by 20 to 30%. So that we are particularly maintaining that if the DO level is less than 2 mg per liter, the blower speed is increasing. And if the this DO level is higher than 2 mg per liter, then the blower speed is reducing. So that is optimizing the energy cost. It requires the less manpower and the supervision, gives instant warning for the failure components, and data easily available for the audits as well as the reporting. Working is based on the sensor collects real-time data, controller sends the data to the cloud processes and the analyzes, system gives alerts or adjusts operations, and operator monitors via dashboard or the mobiles. It can be operated with the Android also. So here overall system architecture is that sensor layers, that is the water quality and the process sensors, edge controller or the PLC is there. For the communication layer, we are able to Wi-Fi or the LoRa. LoRa is used if your DSTP is present in the basement, then it is Wi-Fi or the other is not working. There we have to use this particular LoRa communication model, or the NB IoT, which is working on the 2G or 3G also. Then the cloud platform or the dashboard, and the municipal command and the control center. So overall, a smart automation solution for the seamless sewage treatment plant operations. Automated control uses the PLCs and sensors to manage all processes without the manual interventions. And we are able to remotely monitor that one, enables the real-time access and control via Android smartphones and cloud connectivity. And data logging, continuous record key parameters for performance analysis and the regulatory compliance is available. So sensors we are using are the PS turbidity, TDS and DO sensors. Flow meters we are using for the inlet and the outlets. Level sensors we are using for the equalization and the aeration tanks. And the energy and pump health sensors we are using. So automatic aeration control based on the DO, smart pump and the blower scheduling we have to do. Chemical dosing optimization we are able to make. And the auto backwash and the sludge management. So monitoring and analytic dashboard gives you the live water quality parameters, plant performance indicators, compliance status for the CPCB norms, and the historical trends with the reports. So these are the various sensors we are able to use, and the location where we are able to provide, and what is the benefit for that particular. So the details of the sensors are also mentioned here. So which quality we require, what is the cost of that particular. So PS sensor is normally we require of 20,000 rupees approximately. It is plus minus 10% or 20% is the cost available. DO sensors 40,000, BOD, COD, TSS sensor is approximately 2 lakh. IoT panel cost is causing 45,000. LoRa-based communication cost is 20,000. And NRV automation is 60,000. And PLC panel IoT cost to existing panel is approximately 1 lakh rupees. So approximately we require 5 lakh to 6,000 to convert the existing DSTP to the convention, the IoT-based DSTP. And if we see the cost analysis, the approximately, I have calculated for 100 KLD, the approximate annual cost is, of the maintenance is 9,97,800 for the conventional one. If we provide the 2 skilled manpower, it will reduce to the around about 4 lakh. So within 12 months or 13 months, we are able to recover the cost of the IoT-based solution. And this is the STP process monitoring overview we are able to see. Sewage pump, sludge pump, filter feed pump, air blower, tank level as well as the system modes. And this is the actually video of that particular combined operation video. We are able to see here COD, BOD and the TSS and the PS level actually what is happening there. This is the STP monthly report we are able to get on our Android phone or in the Excel form. So these are the advantages of these IoT-based technologies. So total auto operation of the plant, all STP operation and machinery is operated on the Android phone. All plant operation is logged and stored in the server. 6 months data can be stored in the panel. The data will help to verify the STP complaints. Quality of the treated water can be verified online. Flow of the treated water can be maintained, and it reduces the cost of the operation and improves the efficiency of the machineries. So benefit to the housing societies, it reduces the water bill through reuse, lower maintenance and the manpower cost, order-free and the reliable operations, improved environmental compliance. So that this particular treated reuse of the wastewater is gardening and the landscaping, flushing in the residential building, road washing and the construction use. And as per the norms, we can do the groundwater recharge, because this is depending on what are the parameters are permitted. Implementation model is it can be PPP, municipal empanelment of the vendor, mandatory IoT integration in the society STPs, and perform-based monitoring. What are the challenges and mitigations in these particular? So in these particular, sensor fouling is the problem, so regular calibration is required. Power and connectivity issue, that is the hybrid communication. Skill gap is there, so centralized monitoring and the AMC is required. Data security, we have to secure the cloud platforms. So concluding, IoT-based decentralized STPs are key to the sustainable urban sanitation. It will enable smart monitoring, automation and the compliance, strong support tool for municipal corporations, scalable model for the smart cities and the Amrut mission. These are the references. Thank you.
आले? After this, there are two commercial presentations, number 3 and 4, Amchem products, and SFC environmental. Please come on the dais. कुठून नाही आहे? दिया है? हाँ? तो मैं अनाउंस करता हूँ आपको, आप बैठिए, आपका नाम? रिजवान सिंह मान। आप वो साइड बैठेंगे, नहीं अभी यहीं खड़े रहना। So our third commercial presentation from Amchem products be presented by Rizwan Seeman.
This will be for the next slide now. Namaskar, good afternoon to everybody. My name is Rizwan Singh Man. आप मेरे नाम में एक जोसेफ लगा देंगे तो मैं fully secular name हो जाऊँगा. But I hail from New Delhi, from an army background, from Punjab, and I'm representing our company, Amchem Products. I'll keep it very short and simple because आप सबका बड़ा लंबा दिन रहा है. But more than a technical presentation, this is also full of information that we have gathered in the last 30 years, serving our country and the globe. तो जैसे कि आप देखेंगे, you can see pictures of pipe external and internal coatings. We manufacture the world's #1 high performance direct to metal polyurethane coatings. Now in this there are two things. अभी हमने इतनी बातें करी. India is 18% of the world's population and growing. Now we are the largest in the world. And we only have 4% of the world's available water. माने 18% जो हमारे population है उसको दुनिया का सिर्फ 4% available fresh water है. जिस 4% का 85% हम irrigation में use करते हैं. उसमें से जो बचता है that is used for our daily LPCD for our homes. Now one of the biggest challenges of our country, more than 2% of our GDP every year is lost on corrosion. I'll go to the next slide. For the last 30 years, as you can see, and I'll come back to the corrosion point, हम लोगों ने जिस विभाग पे अपना data represent करके technology represent किया है, all those departments have adopted this technology. They are very happy and they are only promoting it. In Maharashtra, the Solapur pipe water supply, the complete coating of the pipe water supply for Solapur was executed by us. And in India, we've done more than 1,000 kilometers of MS pipe water supply. Currently, we are engaged in India's largest internal and externally polyurethane coated pipes. Of course, we have a lot of man hours behind our product. If I go further, I'll just put a highlight to abhi jaise sabne baat kari, the need to adapt to more sustainable coating, sustainable practices. So if I could just show you on the left, if you could play the video on the left, this is what traditionally has been used. These are layered coatings जो हम use करते हैं, जिनको हम 3LP कहते हैं. पीछे वाली slide. Left पे ऊपर आपको एक वो दिखाई देगा, application process. Play हो रहा है आपको? इसके पीछे वाला प्ले हो रहा है क्या? लेफ्ट वाला? हाँ. So आप देखिए 21वीं सदी में अगर हम if you are to put a pipeline, first you are using, this is what traditionally we have been using and how we replace the entire game. On the left you would see that we are using a lot of heat to make the pipe warm. 300 डिग्री तक आप पाइप को हीट करेंगे. 300 डिग्री हीट करने के बाद पाइप को इंडक्शन हीटिंग के बाद आप एक पाउडर लगाएंगे टू प्रोटेक्ट द पाइप फ्रॉम corrosion, which is a very thin layer coating, over which you would put a intra-adhesion layer. On that intra-adhesion layer you will put another layer to protect it from mechanical disruption. This is called a 3-layer polyethylene. If you can play a video on the right as well. And after you do the traditional coatings, you have to quench the pipe. Means एक square centimeter of the pipe has to be quenched with water. Now, all that effort on one side, and on the right side, all you're doing is applying direct to the metal, one homogeneous coating that protects the pipe for its entirety of service. I'll take you through quickly to the next. These are large dia pipes that we are doing for irrigation in our country. Now imagine if these large dia pipes are with the other technologies, you are expending so much of fossil fuel energy, you are expending so much of money, but the output is not what is desired. Even on the next video, as you can see, you can compare the two most important aspects of any pipeline, which is the jointing. On the left is where you see, play करिए, left और right एक साथ play कर दीजिए. एक side left पे हम लोग joint कर रहे हैं जिसमें हमें gas torches चाहिए. Now imagine putting heat shrink sleeves in today's age in large dia irrigation pipelines and using gas torches to first heat the wraps, apply the primer, all these things. So you need higher gangs, you need a big amount of people. And on the right hand, all you do is you prepare the pipe surface with ST2 tools, over which you apply the coating directly on the pipe. So currently I'm engaged in about 300 kilometers of joint coatings in and across our country, where we are supplying these kits to L&T, Mega Engineering, a lot of the major infra companies. Now, if you can see on the left, that is a traditional way of doing things, which is using torches, and it's basically not feasible. So this is the process basically जो हम लोग traditionally use करते आ रहे हैं, which when I tell my state departments that what's the point of using so much of water, heat, electricity to get an output that usually doesn't last much. When you compare that with direct to metal polyurethane coatings, where you have a pipeline coming in, which is blast cleaned, there is a single spray machine, and on the right hand you have a finished pipe. Similarly, this is the game changer for us in India. अब हम यहाँ सब बैठे हैं, we are all used to Blinkit, Swiggy, Zomato. If any of us today and on your phone you just order a water bottle or you order a Himalaya water bottle, the first thing you see in the water bottle advertisement is BPA free. अगर आप चाहें आप लोग एक नोट भी बना सकते हैं, BPA, BPA free. So BPA is bisphenol A. Bisphenol A is an endocrinal disruptor which has been flagged across the world. No leading developed nation in the world uses epoxy internal lining for its citizens apart from India. However, we are bringing forward that change. I'm currently engaged in two of India's largest internally polyurethane coated pipeline projects across Rajasthan. BPA also is banned by the BIS for drinking water bottles. So up until now, when we go to our state departments who are already in such exhaustive works, we tell them that on one hand, the Bureau of Indian Standards says that any drinking water bottle should be void of BPA. But the very pipeline that's supplying us the water is full of BPA, so that doesn't add up. This is one of the big changes that I have requested wherever I go, I request our departments to look into. Of course, behind me, piche aaye, aage kaise aa gaya? So this is how polyurethane coatings are done on the internal pipelines. The purple pipeline that you see is a ductile island pipe. In India, India is the largest exporter of DI pipes with polyurethane internally lined and externally coated pipes. But our state departments are yet to derive that advantage, which now they are hopefully soon. So this is basically how we are managing the water infra in our country. Traditionally, these are epoxy coatings, and you can see how thin film coatings these are. They are only 406 microns, and they are limited to that thickness due to their design. On one hand, our pipelines are designed for 30 years. ISO 12944 gives these coatings a maximum life of 15. So we are already at a deficit when we are designing our pipes. Add to that the global flagging of BPAs. If abhi sir ne EPA ki baat kari, there is a big study by EPA, IWWA, and it says that UK has discontinued all these things about BPA, which I can share with you later. And of course, with the initial pipelines that I showed, there are multiple papers across the world, including one in India by senior scientists, that share the fact that there has been multiple reports of 3-layer polyethylene pipes that have been disbonding in less than 5 years of service. So you spend so much of energy, you go to the site, it's very difficult to apply, and at the same time you don't get the output. That is how we are changing. And lately now, you can come to our stall number 102. I can share some really nice information, but one of the very, very good informations that we have, if you see on the left, is called NXT SIP. This, for anybody who is from our urban development, from MJP, from any other water department of our country, the SIP means spray in place polyurethane. आज की date में in urban development, you cannot afford to shut down pipelines, you cannot afford to dig up the road and put a new pipe. With SIP, it is a fully structural pipe within pipe coating system. Within 2 hours of us relining your old pipe, it forms a new pipe within the old pipe, and it is ready for use in under 2 hours. I am doing demo for Madhya Pradesh, I'm doing demo for Delhi Jal Board, I'm doing for Maharashtra. This saves the departments a lot of cost compared to traditional cure-in-place coating technologies that charge you upwards of 1 lakh rupees a meter, running meter. This is less than 10,000 rupees a running meter. Same day, no human involved, just the machine goes inside the pipe, relines the pipe. And once it's relined, the coating has no relation with the parent pipe. It is just there to give it shape as a cove. We are currently also engaged with the Department of PUB Singapore for the same. I myself am handling that project, and I am very proud to share with you, and I think aap sab bhi bade khush honge jaan ke, that in the year 2008, Singapore, when it became water independent, 10 years ahead of its time, because they used all their domestic sewage, treated it with high-grade reverse osmosis, and made it into packaged drinking water. That project is called the Singapore NE Water. Not any American, European, or a Japanese company, but your very own Indian company, which is I, did the entire 90 kilometers of Singapore New Water Project in the year 2008. So जब भी हमारे देश beautiful country के भिन्न राज्यों में जाता हूँ, that's what I tell my water departments कि साहब जब वो country जहाँ आप chewing gum नहीं फेंक सकते, सिगरेट नहीं पी सकते, जेल होती है, वो अपने citizens को एक Indian manufacturer के product और technology, which is as per global standards, apply कर सकता है, तो मेरा state department मेरा लाभ क्यों नहीं उठा रहा? And I'm proud to say that now in India, we are leading the industry. We are giving solutions for concrete as well. I have done several CITCO, MIDC, WTPs. I have executed dams, which we are currently engaged in, and since Maharashtra also has a lot of dams, your sluice gates, your downward spillways, everything can be protected. So all in all, the coating is designed to break away from traditional methods that we have been using, and it is designed to give the water departments a direct advantage of cost, which is very, very important in today's age and time. And second is the output. आपने जितना पैसा डाला, उससे ज़्यादा आपको उसका output मिलना चाहिए. So this is one of the things that we wanted to present, and I'd be more than happy to have questions, to have you at our stall 102. Most of the pipe manufacturers that are here, which is Electrosteel, one of the leading DI pipe manufacturers, their entire polyurethane is done by us. You have Jindal Saw, their entire polyurethane is done by us. You have Wellspun, we're supplying to Wellspun. You have Times Pipe that's setting up a new plant, one of your sponsors. So all in all, this is more than a technical presentation. I want to share with you and encourage that all of us should be more aware of the various effects of linings, the advantages of cost-effective products, and also take a moment to appreciate all the workers of our water departments, because just like the army, I think one of the unsung heroes of our country are our water departments, जो इतनी मेहनत करते हैं हमारे घर के टैप चालू हो पानी आए, उसके पीछे की हार्ड वर्क बहुत लंबी होती है. So I'm at your service. I'm at stall 102. Please come and share any questions you have. And if there's any questions right now, I can take them. करेक्ट? अच्छा, आप लोग BIS में भी तो आए थे शायद, राइट, बट आई बिलीव वो फिर डिसकंटिन्यू हो गया था. ओके. Oh, really? Okay. So congratulations. You did, I think, what, 10% of that project? Oh, great. That's very nice. And oh, wonderful. So coming back to what I'm saying, congratulations that other companies are now learning from MChem. We are leading the force. So it's good to see that. Congratulations to you. Currently, well, in India, we've executed more than 10 crore square feet. I'm the first company in the world which you would be proud of, that an Indian company is quoting for US Pipe, which is the world's oldest DI pipe manufacturer. Yeah, any more questions? Yes, sir. Yes, sir. For the SIP, there are two kinds of products. One is structural, where you have a pipe which is damaged, the crown is gone, you need to give a new structure to the pipe. That is a fully class 4 coating. There we go 6 to 12 mm. And in pipes where it is mainly to protect from corrosion, structure is still intact, but there is onset of corrosion. There we offer a 6 mm to 3 mm lining. Sorry, sir?
For the new lines.
So for the new pipes for MS and DI, MS we would recommend 1000 microns for under 1.5 dia and 1.5 microns, 1500 microns for over 1.5 dia.
Either side.
Either side, yeah. So if you're looking at designing a pipe which would last you more than 50 years, the minimum external should be 1000 and the minimum internal should be above 700 microns. That gives you a yield of minimum 35 plus years.
Okay.
406 jo traditional hote hain, they don't last.
I'll visit the stall to get more
Absolutely,
details
sir.
on the
Absolutely. There's a lot of good info I have. And traditionally, there have been various classes of polyurethanes. So the current one that is relevant is the AWA C222 2018. You'd be proud to know that my company is on the global panel of AWA committee. So just like IWA India, which is derived from the American Water Works Association, we are the member panels of American Works Association drafting committee. We are currently drafting the global DI AWA standard as we speak, and we're also a member of the task force. So there's a lot of good knowledge I have, data I have to share with you. And also, one must understand there are various generations of products. So currently, the latest generation of products is the direct to metal for mild steel, and the elastomeric products are more for concrete. So this is also very, important factor, because usually the folklore is कि DTM, PU या PU एक ही चीज़ है. That is where the differentiation lasts and, is created. And also that, we were also instrumental. I must thank Maharashtra Jeevan Pratikaran. They were also instrumental in giving their feedback for drafting a BIS 16719 standard, which was largely drafted based out of the MJP specification. And it is very well adopted now in the country, and we are seeing good results. So that is a good thing.
Yeah, thank you.
Thank you, sir. Thank you. Any more questions? Okay, I'll be there at Sol 102. आप लोग please आइए, and thank you.
No, SFC Environment, hello. SFC Environmental will give their presentation now. Okay? Pradeep Kulkarni.
लेजर नहीं है लेजर
Good evening, everyone, and thank you, IWWA, for giving us this opportunity to present here. What a great football! मैं और मेरा friend सुबह से खड़े हैं, बहुत थक गए हैं. So please bear with us, okay, for some time. So many of you know us from our brand name CITEC, then our company name SFC Environmental Technologies. So today we are presenting here our new portfolio. We have already working in sewage treatment plant, that is heart of the system we are giving CITEC SBR technology. Many of the plants, almost 86 commissioned plants are in Maharashtra itself. So we have tied up with our partner named DuPont, and for the various products which are generally used in the tertiary treatment, as gentlemen from MChem said, we are deprived of the water. So what to do with the existing sewage? We should not dispose it off. We should use the sewage very interestingly in various industrial applications. So how to do it? So first of all, we have tied up with the DuPont, which has three major products. First one is MEMCOR, which deals with the submerged ultrafiltration and MBR technology. Second one is the OxyMem, which deals with the MABR. This is a new technology in the market. And third one is the Desalinitech, which deals with the closed circuit reverse osmosis. Moving forward, this is our portfolio. These are the products. So we will go one by one for each product. First one is submerged ultrafiltration. Previous generation pressurized filtration acts with on the pressure side of the pump. Exactly, submerged ultrafiltration, exactly opposite, works on the suction side of the pump. So it requires lesser pressure and lesser energy compared to pressurized ultrafiltration. It also requires less chemicals, lesser area, and as it requires lesser chemicals, it also has more life than pressurized ultrafiltration system. So why DuPont's or MEMCOR's submerged ultrafiltration? Why not anybody else? So we use 100% PVDF membranes, which has 0.04 micron outer layer, 2 micron inner layer, and 10 micron innermost base layer. And the whole membrane is consist of 100% PVDF membranes. So even during, say, operation maintenance of, say, 6 to 8 years or even 10 years, if the outer layer of 0.04 micron wants off, we have that 2 micron layer which protects our tertiary treatment, and the outlet quality will not be hampered. So also these membranes has highest in industry chemical resistance, that is in the range of 1 million ppm hours of chlorine at 40 degrees Celsius. Generally people hide the temperature. We proudly say we do it at 40 degrees Celsius. And that's why PVDF 100% membranes of MEMCOR. So this is a general view of comparison of our membranes with our competitor, where competitor use nylon as a base material and PVDF as the upper material. So if we go with the second membranes, they get peeled off after some period of time, because the polymer or any adhesive which is binding this layer with base material will worn off because of the chlorine activity, and the membrane will get peeled off. So many of our competitor membranes we have replaced with our 100% PVDF membranes. This is the cross section. And also we can see here the blue line which shows the transmembrane pressure against the time. So after every wash, our membranes are regaining whatever transmembrane pressure was there at the beginning, but our competitor membranes transmembrane pressure was getting increased after every backwash. So what happens, after some time they have to go for early chemical backwash, and as we increase the chemical backwashes, the membrane life decreases gradually. So these are the products. This is the cross-section view of submerged ultrafiltration membranes. And we will see a video explaining all the components of the ultrafiltration membranes. So audio? ऑडियो नहीं है?
System. Modules are arranged into isolatable groups of 4 or clovers.
तो बैकग्राउंड म्यूजिक काटते हैं ओके चालू कर
Isolatable groups of 4
okay
or
the membranes are in clover leaf arrangement
and then onto racks
and they are arranged in the rack form
forming a filter
making a cell
similar to conventional plants.
Depending upon the capacity, we arrange the number of cells.
The filtration process begins as raw water enters.
So water is filled.
Unlike conventional
The
filtration,
filtration is from outside to inside.
raw water is drawn to the membrane modules.
So whatever impurities are there are formed on the outer layer of the membranes.
The membrane fiber
Say after 40 minutes, we need a backwash.
and on the surface of the fibers, while pure water or filtrate is drawn through the tiny pores of the fibers.
This backwash is carried out with patented air and water mixture technology, which cleans off all the impurities which are formed on the surface of the membranes.
Backwash is used. At preset intervals, air scours the outside of the membranes and removes
So this is
solids.
aeration step.
Filtrate water is
followed
then
by
flushed back through the fibers
backwash
in a
by clean
reverse
water.
flow pattern, further loosening solids while air scouring continues. The membrane cell is then completely drained.
Then whatever water
removing
is there,
harmful bacteria and microorganisms.
is drained from the cell.
Once drained,
and again,
raw water is
water which
reintroduced
is
and
to be treated
filtration
is filled
begins
with the
again.
cells.
This entire automated process
This is a continuous
lasts
process,
approximately 2.5
and
minutes
we require at
and
least 2
occurs at
cells
20
to have
90
continuous
minute
output.
intervals, depending on water quality.
So, talking about project references, the Kanji New Water Project, which is in Singapore, which treats the sewage into drinking water. They call it New Water. That is one of the pioneer project from the DUPONT. Second one is Agra Advanced Water Treatment Plant, where 144 MLD Yamuna water is treated with MBBR, followed by submerged ultrafiltration and RO. And Agra city is drinking this water since 2014. After 10 years, due to asset replacement clause in the tender, the contractor who is running the plant has to replace all the membranes. Membranes were working perfectly, but after 10 years, due to that clause of asset management, asset replacement, they have to change it. So after submerged ultrafiltration, we will see what is MEMPulse MBR technology. Everyone knows here what is MBR technology, what MBR technology is. It is advanced version of activated sludge process, which combines activated sludge process with membrane filtration. It removes settling and filtration step, and we put just one MBR tank, which also increases the MLSS to 8,000 to 10,000 mg per liter and reduces the aeration tank volume. So what is different in MEMPulse MBR technology? So generally we have seen in MBR, they put membranes and they provide coarse grid at the bottom of the tank. So what we exactly do, we provide a very huge bubble which comes after every 3 to 5 seconds. So this sharp bubble completely shakes all the membranes and it cleans all the membranes. So this is the major MEMPulse technology. It reduces aeration significantly. As we are aware, in NGT norms, we have to remove phosphorus and nitrogen. If we provide high amount of aeration in MBR cell itself, we will have more DO in the recyclable MLSs, which will go to again anaerobic and anoxic zone, and what our phosphorus bacteria and anaerobic anoxic heterotrophic bacteria will be killed because of this oxygen. So we provide minimum oxygen which is required for only for cleaning. So this is MEMPulse technology. This is the pulse of the air. This is how it happens. After every 3 to 5 seconds, one pulse comes from the bottom. And during bidding of 8 MLD Powai project, many contractors called me and they told me, just check your aeration calculation, you have made some mistake. I told him, no, not exactly. This is our patented technology, which reduces your aeration by 50%. So we are having so many references. This one is in California. We are installing this MBR in Powai for Powai Lake Restoration Project. And after MBR, we will go through the MABR technology. So then literature, we will see what it exactly is. As we are aware of, NGT has recently updated the outlet norms, which requires removal of nitrogen and phosphorus. Phosphorus can be removed very easily with the help of precipitation, with the help of alum and ferrous salts, but it is very difficult to remove nitrogen. To remove the nitrogen from existing activated sludge processes, we use membrane aerated bioreactor. In membrane aerated bioreactor, we provide silicon membranes which provides the air exactly to the nitrifiers. And then after nitrifiers, there is one layer of anoxic layer is there, where these whatever nitrate is formed during nitrification or aerobic zone will go out from the slime layer or bacterial layer, and it will get converted into the nitrogen gas because of anoxic layer. So simultaneous nitrification and denitrification can be achieved in a single MABR module. This is the new technology, we call it advanced IFAS technology. And after whatever air is supplied, this air is collected through airlift pump. For every 1 meter cube of airlifting, 4 meter cube of sewage is drawn from the bottom of the modules. This ensures that all the sewage which will come into the basin will get contacted into these MABR modules or in the contact of the silicon membranes. So this is general aeration step. Here you will not find any aeration happening because air is taken from the side end of the MABR modules. It is not exactly like fine bubble aeration. Also, because silicon membranes have very high amount of area, the SOT of this MABR module is 12 to 15% per meter, which is for most fine bubble aeration is only 6%. And as we are aware, as time passes, biofilm will be formed on the silicon membranes. This will be scoured automatically once in a day, say for 5 minutes. So this is the scouring step, and these are the modules. This is how the modules are installed. So the existing plants of activated sludge process, which are unable to achieve the NGT parameters and removal of nitrogen and phosphorus, can easily achieve the NGT parameters with the help of MABR technology. Last but not the least is the closed circuit reverse osmosis technology. We are aware of the multi-stage RO, where treated sewage is taken from various steps of the RO. This whole system is combined into a single step reverse osmosis, where whatever reject is there is circulated back into the inlet. This ensures that very low fouling and very low scaling will happen in all the membranes. This increases life of the membranes from 3 to 5 years. After 6 to 60 minutes of the cycle, for 1.5 minutes, we will drain all the reject and cycle will continue. So closed circuit reverse osmosis will ensure there will be less power consumption compared to our standard RO system, and it will also ensure low fouling and low scaling, and that increases the life of membranes. So this is a comparison of both the CCRO versus multi-stage RO. So thank you everyone for giving us opportunity to present our new technologies. Please come to our stall number 38 and 39. We have VR, where we have installed our 320 MLD Ongole plant in Hyderabad. You can see the whole plant with the help of VR. And thank you, Ava.
Thank you. Now there is a last lecture of today. I will give the lecture. But before that, there is one announcement about banquet dinner. In the evening, there will be a banquet dinner on MTDC Resort lawn. The event will start at 7 p.m. onwards, and only registered delegates having convention I-card or coupon will get entry in the premises. And like drivers, servants, those who are not having cards will not have entry. So all will join there. Ajinkya. I am Sunil Vaidya. Subject is threat of soft water. Soft water is a threat to life. And मीठा लगता है लेकिन छुरी है मीठी, रोज खा जाती है. Next. I was in the Bombay Municipal Corporation in Hydraulic Engineers Department, and it was always in my mind how to save water, how to conserve water, even while on the tap or a basin, like a hand on a gear, my left hand is always on the water tap. Whenever I need water, I use and again closes. So always thinking on saving of water. What I observed, that Mumbai water is soft water, and what I observed that I need 2 buckets of water to fill that my soap to my body, or in the machine or while washing clothes, more water is required, because due to softness of water, soapy part remains. Whereas when I go in Nagpur or any other place where 1 bucket of water is sufficient, so I thought that why not BMC's water is hard, should not make hard. Then while studying further, the soft water and hard water is not based on any taste or anything, but it is based on the soap. And soft water is 60 milligram per liter. This is a moderate 60 to 120, hard is 120 to 180, and above 180 is very hard water. I also visited to Israel desalination plants in 2012, 3 plants, and it is desalinated water is pure water, and lime is added to make it hard as a mineral addition. So Mumbai water is like a soft water, like less than 100, like RO water. So it can be made hard, and it is good for health. I am coming to that. The TDS of Mumbai water is 55 ppm, that is less than 100 ppm. And by adding minerals, it can be increased. There is no study or any article to make water hard, except in the desalination plant we do this. But most of the lectures in the literature review was how to make hard water soft. This is the important thing I want to stress, that soft water is aggressive, it is unstable, and it absorbs whatever in their surrounding. Even in swimming pool, we find pits in the walls, tiles walls. It takes minerals from the concrete and iron pipes and everything. When rain falls, in the rivers, it gets minerals get dissolved and it becomes hard. But in the terrains like Mumbai and Konkan and many areas, water falls and collected at there itself only. It doesn't travels and minerals doesn't get absorbed in that. So the water is soft and it tastes sweet. Unless minerals are intentionally added, such water dissolves minerals from concrete stone that I have told. Increasing minerals in small case is possible because there are liquids. A drop can raise by 100 ppm hardness. And we can add lime or any other things to make it little hard, at least more than 100. These are some data I collected. Mumbai is 40, whereas Nagpur 118, London 275, UK 268, Canada is around 120, Brisbane is 100, and Adelaide, Australia 134, 148. In USA, almost everywhere it is at least 125. These are two reports, analysis reports I have collected. These are the regions: Mumbai, Navi Mumbai, Thane, Palghar, Raigad, Ratnagiri, Sindhudurga and Kolhapur. Mumbai alone is more than 1 crore, 1.5 crore. Now these are the probable effects on water treatment plant, WTP. If we add some hardness for lime or something, there may be some little effect for coagulation and chlorine dosages. That might have to be increased, but the study will need to do. Now this is one thing. People think that consumers will require higher doses of soap when water is hard. But there is one study which states that even if water is hard, the soap process remains same. It doesn't require that you should have more foam, and that is good for washing. The study further says hardness affects hardness versus cardiovascular disease. Even in our Khanna's handbook, it is written that where is the soft water, cardiovascular diseases are more. The US National Research Council report says that drinking of hot water can serve as dietary supplementary for calcium and magnesium. It is to note that we are taking soft water and we are not getting calcium, magnesium supplements, and we eat something of calcium. That doesn't solve our problems, because absorption from solid material is time consuming. This is one economical thing I want to say, that if at all, by making water hard, and per day per person, if 25 liter water will be saved, the Mumbai can sell a lot of water per day. But I am not stressing this point. Water hardness is very, these are my conclusions. So I am stressing soft water is a threat because it affects on our body. It absorbs minerals surrounding the anything, and also from body it absorbs calcium, magnesiums. It absorbs many minerals from our body, and osteoporosis occurs and many other diseases occurs. And that's why soft water is not good for the health, and we should drink it by making it hard. I want to play a small video in which it is mentioned about hello. In this video, in the hello. In the video, it is mentioned everything about how RO water having TDS less than 100 mm is dangerous to health. The same is applicable for the Mumbai water, which is having hardness or TDS about 50. So please watch. Thank you.
It is estimated that 80% of urban Indian population is deficient in vitamin D, the sunshine vitamin, in the country.
Recent reports suggest 8 out of 10 people in Delhi suffer from vitamin D deficiency.
The strongest probable cause is RO water. Yes, RO water. WHO report reveals disturbing facts in health risks from drinking demineralized water. WHO says in search for clean drinking water, we remove many essential minerals from water. RO water actually causes health problems. WHO also released a report, after analyzing hundreds of scientific studies stating that RO water has a definite adverse influence on humans. A similar study was published in medical journal Armed Forces India. Demineralization of drinking water, is it prudent? Czech and Slovak health regulators were aghast when health complaints of acute magnesium and calcium deficiency were reported within weeks of RO water being used in home taps in 2000. RO water is mineral hungry. RO water wants to bond to everything, and it will take the minerals where it can, like in your food and body. When it is consumed, it extracts minerals from your body. Calcium, vitamin D, and magnesium, the calming mineral, get removed from your body by RO water. Scientists further studied that this mineral loss was not compensated by our diets. Consumption of RO water leads to the dilution of the electrolytes dissolved in the body water. Minerals being consumed in food and vitamins by you are being urinated away. RO water leads to deficiency in calcium, thereby leaving us with osteoporosis, arthritis, depression, mood swings, irritability, bone loss, hair loss. RO water also leads to deficiency in magnesium, thereby leaving us with diabetes, fatigue, insomnia, hypertension, heart disease, osteoporosis. Epidemiological studies suggest that RO water may be a risk factor for society. Our ancestors used to feed on water. Now, RO water feeds on us. Time to wake up. RO water with 50 to 100 TDS is bad for health. Please consume water with 300 to 400 TDS only. Or adjust your RO water machine to provide water with 300-400 TDS. You can check your TDS at home with a TDS meter costing only rupees 150. Issued in public interest.
Thank you. With this, we conclude our sessions. And thank you all participants and Chairman Qureshi sir. So there are two more announcements.
There is a Layu ferrocement tank construction shall be commenced around 4:45 to 5 p.m. outside exhibition area. Secondly, Eco Sattva Environment Solution is Nivedita Tul is there. I invite her on the dais. She want to appeal you for a visit for a calm river regeneration which they have planned. She will talk 2 minutes on it.
Good morning, good evening everyone. इतने सारे diverse stakeholders को संभाजीनगर में साथ देख के अच्छा लग रहा है. आपकी convention को attend करना was a pleasure. Eco Sattva एक local organization है और पिछले 5 सालों में हमने एक बहुत interesting और meaningful project पे काम किया है water related. कल कमिश्नर सर ने भी उसकी चर्चा की थी. खाम नदी औरंगाबाद संभाजीनगर की पुरानी नदी है जो एक नाले में तब्दील हो चुकी थी. पिछले 5 सालों में म्यूनिसिपल कॉरपोरेशन, कॉलेजेस, स्कूल्स, कॉर्पोरेट्स और हमारी ऑर्गेनाइजेशन ने इस नदी पे काम किया है. हम लोग ऊपर से नीचे तक काम करते हैं, मतलब वेस्ट मैनेजमेंट ताकि कचरा नदी तक नहीं पहुँचे. उसके अलावा असली में नदी को बड़ा करना, ड्रेजिंग, डीसिल्टिंग, सीवेज ट्रीटमेंट एंड फिर फाइनली उसके अराउंड बायोडाइवर्स स्पेसेस बना के वहाँ पे बच्चों से लेकर सीनियर सिटीजन्स को इकोलॉजी, एजुकेशन के बारे में बताना ताकि उन्हें भी पता चले कि हमारे शहर में एक नदी है और वो नदी धीरे धीरे जिंदा हो रही है. So, on behalf of Eco Sattva Environmental Solutions, I would love to invite all the different delegates and participants for a nature walk at the Kham River tomorrow. We will be starting at 8 o'clock and it will be an hour-long walk. I would love to show you our work and get insights from the different engineers and the different stakeholders from different organizations that we have here. Because a little miracle is sort of coming to life in this city. And since you're all here, it would be a pleasure to show you what we're doing and get your insights. So if there are a few people who are interested and would be able to make it tomorrow, it would be really wonderful to show you the work we are doing. Thank you.
stall.
आणि परत येऊ.
Delegates, thanks that we can conclude two sessions because one or two absentee and you be patient over here. Now we can move to the ferrocement technology storage tank construction is going on outside in the premises. We can visit stalls also. And at 7 p.m. onwards, 7:30, we will meet at banquet dinner in MTDC Resort. Thank you.
लास्ट सेशन सरकारी हुआ ना? रिमोट नहीं दिला.